What's up, everyone? Vin here, and we're doing the AP Calc live stream day 2, and we're doing units 6 through 10. I made a link in the description that will get you to the practice questions that we're going to be doing, but we're doing 50 multiple choice questions going from units 6 through 10. So this is good for Calc AB and BC. The BC questions are going to be for the later part. So AB people, at some point, things may not look familiar, but you're welcome, of course, to stay the whole time. And hello to everybody who's here, who's waiting. I'm happy to have you all on board. And I do recognize some names in the chat. So at William and Nanoa, hello and welcome aboard. And yeah, here we go. We're just going to get moving here. So if you have questions, you know the deal. Just throw them in the chat. The only thing I do ask streaming guidelines is just, being respectful to each other in the chat. That's it. That's all I really care about. And yeah, let's do some math here. So how do I find the sum of a series? So the sum of a series at Arhan, it depends on what kind of series you have. If you have a geometric series, then you're going to do first term over 1 minus r. If you have a different kind where you could find the nth partial sum, then you could take the limit as n goes to infinity of the nth partial sum. Okay, so that's mainly like your two strategies. Or if you could express the power series, if you could express it like as a common power series, like an e to the x, sine x, cosine x, that works too. But as we move through the live stream, I'm going to get to series, so I'll revisit that again. Okay, so here we want to evaluate this integral. So this one I could just rewrite as integral 0 to 8 and then 1 plus x to the negative half power, and then dx. Now, I could do u sub here, but I don't have to do u sub here. The reason being, if I define my u term to be 1 plus x, so I have 1 plus x, then du is going to be equal to dx. So if your derivative of your u term is 1, that means you could just ignore U-substitution and just go. So here, I'm using the fundamental theorem of calculus. I'm going to do the antiderivative using power rule. So I'm doing plus 1 to the exponent to get negative 1/2 plus 1 is a half. And then I divide by a half. But dividing by a half is the same thing as multiplying by 2. So I'll just throw a 2 in front. And then we're going from 0 to 8. So now I leave my constant on the outside attached by multiplication. And we're going to have 1 plus 8 to the 1/2 power. And then we have minus 1 plus 0 to the half power. So, hey, Vin, about what question do the AB level questions end? Oh, okay. So if I zoom ahead a little bit, I would say like around 30 something. So 32, yeah, 32. 31 is the first BC question. Okay, but that's on a page with AB stuff. So 31, yeah. So question 31 is it. That would be where I would stop, stop printing to save paper for sure. So here, this is now 2 times the square root of 9. See, this is 9 to the half power, so I have the square root of 9 minus, oh yeah, and this is to the half before I scrolled. So I have minus the square root of 1. And now this is 2 times 3 minus 1 is 2, and that's equal to 4. So choice D. All right. These questions do take a little bit longer than yesterday. So I'm going to not rush, but I'm going to like move a little bit, faster. Not crazy fast where no one gets it. So here, 2 ways we could do question 2. We could draw it out or integrate piece by piece. We have a piecewise function. So for this one, if you just want to draw it out, we have y equals x when x is less than 2, which is going to look like this. So here's y equals x when x is less than 2. And then when x is greater than or equal to 2, we're up here at 3. So then it becomes this line. And we want to know the integral from negative 1 to 1, which we could just find the signed area under the curve. Okay, so we're going to go here. I'm going to put that in red. And then this I'll put in purple. And then we're going from all the way out to 4 here. So then the last piece, we're finding this. Okay, so if you just want to use geometry, you could use geometry here and say, like, this is going over 2 and then up 3. So 2 times 3 is 6. This over here is a triangle, a right triangle. So I could just go over 2, up 2. So I'm doing 1/2 base times height for the triangles. So the base is 2, the height is 2, and half of 2 times 2 is going to give us 2. But this one is a 1 by 1. I didn't draw this well. Like, I didn't, I could have marked the 1 a little bit better, but we're going over 1, down 1. So 1 times 1 and then divided by 2 is a half. So when we evaluate this, just using geometry, we have 6 plus 2. However, we have to be careful and treat this as minus, okay, as negative, because it's under the x-axis. So here, this is just 8 minus a half, which is 7.5. And that's the same thing as this. Okay, so that's one option. Your second option here would be to integrate this piece by piece. So you could go from -1 to the transition point is 2, and less than 2 is determined by x. And then you can complete the rest from 2 to 4 using y equals 3 as your function. So if we just do what we did in question 1, but just twice, this also should give us the same answer. We have 1/2 x squared from -1 to 2, and then plus 3x from 2 to 4. BC student, I am screwed. Just do your best. Learn as much as you can from now to Monday. That's really all anyone can do, right? Is just do your best. And yeah, just putting in your time is worth it. I would say it's better than not putting in the time. Like, it's AP Calc. I like the class because it's like a chance to get a feel for what college level math would be like. So, good luck to all of you. So let's see, 1/2, I plug in 2, I got 2 squared minus -1 squared plus 3 times, I plug in 4 and 2 and subtract. So now here, this is 4 minus 1 is 3. So I get 3 times 1/2, or 3/2, plus 2 times 3 is 6. And then this is going to be the same thing. This is 3 over 2 plus 12 over 2, which is also 15 over 2. Okay, so either way, the math is going to give us the same thing. All right. So next up is the trapezoid rule. So for this one, let me see if I can zoom in here a little bit more, because this one's like a little bit tricky to see. So they're saying calculate the approximate area using the trapezoid rule, using divisions at 4/3 and 5/3. So that's 2 divisions, which is going to break this into 3 subintervals. Okay, so I wish the picture was like a little better, but I mean, whatever. It's still a good question. So 4/3 is over there, and then this one is 5/3. So what we should imagine here is, if I draw this like really, really small, let me just scale that down. Could we? Oh yeah, we could see this, hopefully. So I'm going to go 1, and then I'm going, let's say here, and here. Okay, so I'm going 1 trapezoid here, a trapezoid here, and a trapezoid here. Okay, I just wanted us to be able to see this. All right, now I'll go back to, us being able to see what's going on. So the formula for the area of a trapezoid is 1/2 height, base 1 plus base 2. But the catch here is that the change in x, if I'm going from 1 to 4/3 to 5/3, I'm counting by 1/3. Okay, so these 3 trapezoids have a base of 1/3. So I'm doing 1/2 times 1/3, and then I'm doing the sum of the y values. So notice here that we have at 1 and 4/3, the function is this. See how this is over here? So, you could go ahead and, let me just zoom out a little bit now that we have that. We could go ahead and just, make a table. So let me just get rid of this stuff over here. So I'll go ahead and do that. I'll make a table. And I would say this question is like borderline unfair without a calculator. Kind of annoying to do without one, but whatever. I guess it's good practice. So x, y, we have 1, 4/3, 4/3, 5/3, and 2. If we square it using the function 1 squared is 1, we square this, we get 4 times 4 over 3 times 3. Then we get 25 over 9, and then we get 4. So the first trapezoid, you see, is like 1 and 4/3. So the bases are the parallel sides. See, like the bases are all here. These are the bases. So I would have inside the parentheses here, I have 1 plus 16 over 9. If you just know that these middle values get doubled, then great. Otherwise, just do it the long way like this. Okay, then we have plus 1/2 of 1/3 is the height for the second trapezoid. And the second trapezoid has these two bases are 16 over 9. I'm sorry, fix that. 16 over 9 plus 25 over 9. Okay, and then the last one is 1/2 times 1/3 times, and then we have 25 over 9 plus 4. So you can see here that the middle values, 16 over 9 and 25 over 9, get used twice. So then we're just simplifying that. I'll just write it over here. So we get 1 over 6 times, and then we have basically 1 plus 16 over 9. See, like we have 1/2 times 1/3 is a sixth. And this is 1 plus 16 over 9 plus 16 over 9. So I just double that. I get 32 over 9. And then I double 25 over 9 to get 50 over 9. And then I just do plus 4. Okay, so this is 1/6 of 1 plus 4 is 5. Plus 32 plus 50 is 82 over 9. And then 5 I could just call 45 over 9. So I'll just rewrite this like 5. I'm going to call 45 over 9. And now 82 plus 45 is 127. And then I would have over 9, but times 1/6. 6 times 9 is 54. Choice D. Okay, 3 should be choice D. Crazy stuff. Oh, predictions. Yeah, I would say this year, like, I wouldn't be shocked if it's polar because it's been parametric so many years in a row for BC. I don't teach AB anymore because, like, I teach BC at my school, but I teach AB, I guess, because I teach everything on units 1 through 10. So, yeah, I'm cooked. No, don't. I was saying you don't want to be cooked. You want to be the chef. All right. So I want you to do the cooking. Just study up, and you can put on your chef hat. All right. So, okay. So this one is a big formula you need to know. I'm going to write that the integral from 0 to 1 of f prime of x dx equals, and fundamental theorem of calculus. Oh, wow, we have 35 people on. Thank you all for being here. I really am, like, just, I said it yesterday, but I can't say it enough. Like, just grateful to have, like, this type of community and that there's, like, that many of you supporting. Like, just thank you. This is, like, bigger than a class that I would teach. The max class size is in New York is 34. So, thank you for being a part of this. Like, I really do appreciate you all. Oh, I shouldn't say 1. How about I say 2? And I'm saying 2 because we want to know what f of 2 is. If I wanted to find f of 1, I could use that. So if I want to find this, I'm just going to do plus f of 0 to both sides. Okay, so f of 2 is equal to f of 0 plus the integral from 0 to 2 of f prime of x dx. All right, and the rest is calculator. You just type in. Right, let's see. So here, I'm doing f of 0 is 1. So 1 plus, math 9 pulls up the integral. 0 to 2. And f prime is sine of that mess. I'm going to write alpha y equals enter to pull up a fraction. And we have pi. We have pi. And then e to the x over 2. And then we have to write dx over here. And we get 1.157. All right, I hope that's okay. So 1.157. Yeah, let me just get out all the extra fluff. That's the one thing with the live streaming is like when I make my videos, I edit this part out, like me doing all the cropping and all that stuff. So yeah. All right. You just got to see this, I guess. Cool. So this is choice E. If you forget to do f of 0 plus, this answer is waiting for you. Okay? Like, please don't choose that. This is like the saddest answer choice. All right. Do I expect Unit 8 FRQ, anything like that at all? It's possible. I mean, the old test, they used to always ask Unit 8. And then it kind of got replaced by rate in, rate out. But Unit 8 is fair game. Unit 8, look, you could still do really well on the test without being great at volume of revolution or without being great at, what's the other one? Like Cavalier's principle. Those are like some of the hardest topics, even for BC. Like I would say Unit 8 is like kind of tough. So, all right. So here I'm going to do a U sub. I want to integrate this. So U equals 1 minus 9x squared. Now du, the derivative, we have minus 18x. I'm just doing 2 times negative 9 is negative 18. X to the 2 minus 1. And then dx. Now here, there's two ways you could go from here. You could solve for dx. Some teachers show it that way. I personally, after I do a lot of these, like to solve for the leftovers. Like I just want to get x dx here. So I would just divide both sides by negative 18. And then what this gives us, I'm going to write it like this. Negative 1 over 18 du is equal to x dx. So now I could actually do the substitution. Okay, I'm going to do integral of negative 1 over 18 du over square root of u. And now this will simplify to, first, I'm going to call this u to the negative half. Then I anti-derive. So you got to be good with your algebra. You got to be able to like move stuff around like this to be good at your antiderivatives. So I add 1, I get positive half. I could divide by a half, or I could just multiply by the reciprocal 2. Okay, so I could put my times 2 in front. And then don't forget plus c, even though all the answer choices have them. So now 2 over 18 makes 1/9. So I have negative 1/9. And then u to the half, I could write u to the half, or I could say radical u plus c. And u is 1 minus 9x squared. So 5 is looking like A. And it is. You could also like derive the answer choices if you want to, go that heavy. That's possible. Oh, how can we get the questions is in the description. And the answers, I guess, watch the live stream or chat GPT or Wolfram Alpha. Yeah, I didn't put an answer key up for this. I don't like, I'm just like going to do it. Yeah, here live. So, but yeah, in the description, there's a PDF, a link to a PDF in a Google Drive. All right, this one is a nice question. Don't use sub this. Call this x to the half and then distribute. Okay, so I'm going to use the distributive property. And I'll write it over here. So integral of, think of that as x to the first. So algebra skills. X to the half times x to the first is x to the 1 plus a half, or 3 halves. And then minus x to the half times 1 is x to the half. Dx, and then now we add. I'm sorry, we anti-derive and add. So x to the 3 over 2 plus 1 is 5 over 2. And then 2/5. And then minus x to the power 1/2 plus 1 is 3 halves. And then 2/3. And then plus c. So this one is looking for the 2/5 like this. Okay, remember your power rule. Like this, I kind of just went fast, but you should absolutely like have this rule down. Okay, your power rule. And you use this as long as n is not -1. Okay, that's how you're going to anti-derive. So, all right. So moving on. Ah, this is a good one. 7. 7 is the FTC with chain rule. So if I have something like this, u of x, p of x, and it's f of t dt. Just think when I derive an antiderivative, like derivative of an integral, they're opposites. They cancel, leaving you with the integrand, but it's the integrand at the upper limit times p prime minus integrand at lower limit times q prime. So here, honestly, when I do this, dy dx is 0 plus. This tells me plug the upper limit in for t. So plus e to the negative and then 2x squared. Like this is like f of p of x. Like what I just did here is I plugged in the upper limit to the integrand. That's this part. And then p prime, the derivative of my upper limit, 2x, is just 2. So this is like lining up with, just in case we're like, what's happening here? This lines up with this. Okay, and then the rest, I have minus. I could plug in 2. I could write e to the negative and then 2 squared. But then when I multiply by the derivative of 2 is 0, this part just wipes out. So then dy dx equals e to the negative. The negative is on the outside, so it's going to definitely be negative. And then we have 4x squared, because I'm doing 2 squared is 4, and then x squared is x squared. And the times 2, I could just write in front like this. So I need 2e to the negative 4x squared. So goodbye, goodbye, goodbye. Now the $1 million question is, like, which of these is it? All right, make that 2 a little better. Yeah, that's better. So here, well, let's think. The 5 plus in the front is kind of giving away that we want the integral to 0 out. And integrals go to 0 when you have like integral a to a of like, let's say f of x. This is always equal to 0. Okay, so that's like the concept we're looking for here. So that's why e is jumping out as correct. Because if we plug in 1, y of 1 is, let me fix that, 5 plus integral from 2 to 2 times 1 of e to the negative t squared dt. So this is equal to 0 because of this idea, and it's just equal to 5. All right, if I made it 0, then it would be like the limits aren't the same, so e to the negative t squared looks like this. So it would be like a non-zero area that we're dealing with, and that would change it, would make it not equal to 5. Oh, can I explain the fundamental theorem of calculus? So FTC, I've been saying that, there's really 2 kinds. Like FTC is integral a to b of f of x dx is capital F of b minus capital F of a. And this is where capital F of x is an antiderivative of lowercase f. And now the less popular one, but still important, FTC. So FTC, some people call it FTC too, but I'll just say like the other FTC is when you derive an area function like this, where it's a constant to x. This is equal to f of x. Okay, they're both important theorems. So it depends on the textbook. I've heard this one. I mean, I like to call this one first because I think it's like it's more commonly used. So like, why not call it first? But I've seen other books call this first and this second. So it depends on the textbook, like who wrote it. Sometimes like the math people can't agree and make life easy for everyone. They need to, I don't know, like resolve their issues. All right. So this one uses that other FTC. So here, well, actually, it uses the concept that the definite integral tells you the area under the curve. So g of -1 is equal to the integral from 0 to, see, x is up here, -1, and then f of t dt. And they gave us a graph of f. So first what I'll do is I'll flip the limits, but you can't just flip them and hope no one notices. You got to throw a minus in front. And now this is minus, and I'll leave a space for our work. So for the rest of this here, I like to put the lower limit as the less than number. Like -1 is less than 0, so I like to put that bottom. That's why I flipped it. Because now I could just go and find this stuff from left to right. So I'm going from -1 to 0. And here's the function. And notice that the area under the curve we could find by finding the area of that triangle form. Okay, so we just find the area of this triangle. This is 1 and this is 2. So I'm doing half base times height, or half height times base. And the area of this is 1. So I have negative, and then I have 1 like this. So this is going to give us choice B. Okay, 8 is choice B. Don't you have to take the derivative of -4x squared and multiply it to e? No, the reason being is we're deriving the integrands, not the integrand, we're deriving the limits. It's f of p of x p prime. This is the function of t, okay, that we just plug in. So we're not deriving that. I could do a proof of this theorem. Like, that's why I like to show proofs in class so that people actually like get the process. But otherwise, yeah, it's like the proof is really just the fundamental theorem of calculus and chain rule. Like, that's why the theorem works. So, all right, but yeah, just this formula is good. Just, I would know this formula. All right, this one, oof, so 9. Riemann sum notation for definite integrals. So you want to know this one. For some reason, they just love right Riemann sums. I don't know. They can't they're not like ambi Riemann summers. They just only Riemann sum right. College board. But it's their choice. So here, let me see. We're going n equals 1 to infinity. And it's f of a plus k delta x times delta x. Oh, I'm sorry. Wait, I should say it different. I'm not talking about unit 10. I forgot. Calc AB. So if I'm using k, let me do this. So I got to just mess around with the letters a little bit. So k equals 1 to n. That'll work. Yeah, in different settings, I could use infinity, but I won't do that here. And this is the limit as n goes to infinity. There we go. That's better. So looking at what we have right now, the mental check that I do for myself, just to make sure I'm doing this right, the integral from a to b. If I'm doing a right Riemann sum, and I break this up into a few subintervals, and all of these are like delta x, they're all jumping by the same amount. When I have k equals 1, a plus delta x puts me starting here. Okay, so that's how I know I'm setting this up right, and this formula is good. So then once you have the formula down, honestly, it's just a matter of little by little just defining each piece. So this integral in the question, I just go piece by piece and find everything we need. So I have, all right, a is equal to 2. I have b is equal to 6. I have f of x is square root x. But now delta x is going to be the main formula you would need to know. It's b minus a over n. Yes, this is going to be posted at Mini. The replay will be on my playlist. In my channel live section. So yeah, not to worry. So b minus a divided by n. So I'm doing 6 minus 2 divided by n is 4 over n. So that's delta x. So now the formula, this is probably the part students struggle with the most, is finding this, f of a plus k delta x. So in this case, I'm going to find f of a is 2 plus k times delta x is 4k over n. See that? I'm just doing like delta x is this. And if I multiply by k, I get 4k over n. So that's going to give us the square root of, I have 2 plus 4k over n. So now I just piece all of this together. All right, I'm going to say here, I'll even write it over here. And maybe I'll do a different color. Switch it up. We'll say this is using the formula, the limit as n goes to infinity of, not integral, sorry, sigma k equals 1 to n. And then we have f of a plus k delta x is this piece. So it's really just like patience and algebra, like algebra and patience. And then times delta x on the outside. So I have an extra 4 over n outside of the radical, which in the answer key, they wrote it in front. So this one, 2 plus 4k over n, looks like this one. All right, 9 should be choice C. Not an FRQ. So look, at SASA, if I'm saying it right, really, what I tell my students, the first time you look at this equation, it's like, whoa, this is insane. But if you think about it, like you just go piece by piece. You're like, all right, in this case here, a is 2, b is 6, delta x is 6 minus 2 over n. And then f of a, like this is the part like where you want to be careful. Like just be careful here. So this, you see how it's like f of a plus k delta x. A is 2, delta x is 4 over n. So when I multiply by k, I get this. And then it's just plugging it in to this function. I replace x with that mess. Okay, and then I just plug into the limit thing. I just, like, for formulas like this, you could do like a little bit of a deep dive and see that if I do right Riemann sums here, that this is, like, that's why the formula works. Is that, like, I start on the right, so I start at this point over here. That's why I'm doing a plus 1 delta x first. And this would be a plus 2 delta x's. I go 1, 2 delta x. And this would be a plus 1, 2, 3 delta x's. And that will, you know, eventually get me like n jumps. Like if I broke this up into 1, 2, 3, 4, 5, I do 1, 2, 3, 4, 5 delta x's, brings me to my last rectangle. All right. So yeah, that's cool. So moving on. How do you get over n? Over n, that's just the idea of the formula. So over n is really just like y is delta x b minus a over n. So this one, if you just think about it, let's say I want to break the space up from 0 to 8. I want to break this, like n is the number of like subintervals. So here, if I say n equals 4, think about this. How many, like if you break 0 to 8 into 4 equal pieces, you're going like this. And then how long is each piece? Well, you do the number on the right minus the number on the left divided by the number of subdivisions. So this tells you to count by 2s. Then you're going, oh, all right, 0, 2, 4, 6, and then 8. That's the way. All right, these summation questions is at most one multiple choice question. So it's worth, in the grand scheme of things, it's worth 1.2 points. Okay? So this will not ruin your score. If you don't know this, it's not going to wreck your score. If you don't know this, that will destroy your score. This is like a real, like, this is like a big formula. Okay, and so is this. I would say this one's important too. Like, not as big as this one, but it's definitely a big formula. Like, know these two. All right. Oh yeah, we don't know n because n is going to infinity. That's the idea. The concept of a definite integral is that like a definite integral tells you the exact area under the curve. And in the beginning of unit 6, you do that with Riemann sums. Like you're just approximating. You're like, all right, I'm going to do like 2 rectangles. And you're like, whoops, I over approximated. But if you made like 10 trillion rectangles, you made them like super, super, super skinny, then the error is going to disappear. So yeah. If you don't know, is there a way to eliminate some? I mean, if you had a calculator, I guess you could just plug in like this in the summation and then see that it's going to give you this. So, but if you don't have a calculator, then this is really this is hard to do in your head. Like, because then this is like kind of like unit 10 territory, which is not an A-B topic. Even for unit 10 people, this is like hard to like try to find an nth partial sum. Some cases you could do that. Other cases, like you really can't. So you just got to know the formula. It's one of those situations that it's like hard to work out of. All right, so this one we have h of x equals this. On what intervals is h increasing? So h increasing, I'm thinking h prime greater than 0. Like that's the idea. This is what we're looking for. So this, I'm going to take this equation here, and I'm going to derive both sides. And there's that big formula I was talking about. This formula that I'm writing here, like the derivative of the, area function, is almost guaranteed to show up in the free response. The graph of f prime question is like basically going to be there. Whoops, is g of x. I'm talking too much. All right, is g of x. So you see I'm using that FTC formula once again. I'm using this one. The derivative of the integral from a to x of f of t dt is f of x. Like basically like the derivative and the integral cancel out. That's how I think of this. So using that idea over here, it's like the derivative and the integral cancel. And what that tells us is that this graph of g is also a graph of h prime. So when is h prime positive? We just look, when is the graph positive? Here and here. It's when the graph is above the y-axis. So that would be from 0 to 1 and from 3 to 7. Okay? It's tempting to say, oh, 2 to 5, but no. That would be if this was a graph of h, not h prime. Cool. All right. So here, question 11 for me was like kind of borderline. Meaning like I have to look at this a second time to see Roman numeral 3 was the one that like annoyed me the most. And you'll see what I mean in a moment. So we start this by saying, okay, g prime of x. And notice it's integral from 1 to x. So g prime is just the integrand, but instead of t with x. So 100 times x squared minus 3x plus 2 times e to the negative x squared. Okay, so here it is. G is increasing. Tells us to just look for where is g prime positive. Okay, so this is what we want to know. Now, the trick here is noticing like, oh, these things. This is always positive. 100 is just a positive constant. This, e to the negative x squared, is sneaky, but it's always positive. Okay, e to the negative x squared on its own looks like this. It never goes under the x-axis. So this is always positive. So the sign of g prime entirely depends on this piece here. And what I'm thinking of when I see this, I'm like, oh, this is a quadratic that's smiling at us, which is going to be relevant in a moment. So I'll say here, when is g prime equal to 0? G prime is equal to 0 when x minus 2 times x minus 1 is equal to 0. This is never going to give us a 0. This will never give us a 0. So this will be when x equals 1 and x equals 2. So from here, what I do is I make my sign chart. So g prime, here's my sign chart, going from 1 to 2. But remember what I said before? G prime is going to look let's see, something like this. It has two roots at 1 and 2, but it goes plus, minus, plus. It's like over, under, over. So here's our sign chart. So from 1 to 2, g is decreasing because g prime is negative. So this one's out. See, notice here, g prime is less than 0, so g is decreasing on this interval. From 2 to 3, yeah, for 2 to infinity, g is increasing. And 2 to 3 is a subset of this. So this is true. So 1 only is out, 3 only is out, and 1, 2, and 3 is out. So it's really a matter of, is 3 true or not? Now, one of the challenges here is that if this is no calculator, it's this one I would say a calculator, like for this part, would be fair game. Like the question might be just like a little like poorly constructed. And I'll show you why. Because, let me just shrink this down. What we have to kind of investigate here is something like, oh, g of 1 is the integral from 1 to 1 of, I'm just going to call that f of t. I don't feel like rewriting all that stuff. So g of 1 is equal to 0. So then here, what was annoying is g of 3, if we pay attention to it, g of 3, if I'm doing this no calculator, would be g of 1 plus the integral from 1 to 3 of g prime here. So I'm basically, actually, you know what? I'll just write it out like this. G of 3 using this is integral 1 to 3 of our function, 100 times this. But what's standing out at me right away is a few things. That g of 1 is equal to 0. But then from 1 to 2, like on this interval, like g is decreasing. Okay, on this interval here. But then g starts to increase. But the question is, does g increase fast enough to get back to the positive? Because like g of 1 is 0. So when g decreases, it goes negative. But does it recover fast enough without a calculator finding g of 3? Like, we're not going to anti-derive this. Like, that would just be kind of insane. I mean, if we really had to, we could separate and do math for like 5 hours. But honestly, here, it's just, I think, more valuable just to, jump to the calculator. And plus, we could just review how to use this calculator properly anyway. So here, I would just investigate, math 9, integral 1 to 3. And then we have 100 times, and I'll use x. It's not going to matter. I could use t, but I don't feel like using the alpha selection here. Okay, to the negative x squared. All right, and then this, see, it's negative. So g of 3 is not less than 0. So it doesn't recover that decrease. Okay. Integrate, I have 50 questions. Maybe like at the end, if it's not like midnight, I'll come back. Or I'll do that as like a separate video. Okay. So yeah, like it's just, I feel like on the AP test, the theme is not let's spend 25 minutes integrating something. It's got to be more about the ideas. Okay. So just here, g of 3 is not, what's it called? G of 3. Wait. You know what? Let me just make sure. Let me just type that in one more. Let me just read what we have. So g of 3. Oh, I'm sorry. Did I write this? Make sure I just want to make sure that I'm writing it incorrectly. Yeah, g of 3 is integral 1 to 3 of 100 x squared minus 3x plus 2, and then times e to the negative x squared. This came out negative. So g of 3 greater than 0 is not a true statement here. Okay. Oh, why is that the case? Oh, wait, why is this not writing? Because if you were to make a sign chart here based off this, so let me let me just zoom out a little bit. If I look at when I plug in, let's say I plug in 0. So G prime of 0. So I'll do this. G prime of 0 is 100 times 0 minus 0 plus 2 is 2 times e to the 0. This is a positive times 1 is positive. I could plug it in to here, but once again, this is always positive. This is always positive. So this on its own is really going to like determine the sign of G prime in the sign chart. Okay, because I just know when I plug in any number, I have a positive times a positive at the end times whatever this is. So the fact that this is positive, like this piece, x squared minus 3x plus 2 is positive, negative, positive, like, you know, here before, between, and after the roots, then I'm doing, just say I'm doing a positive times a positive is positive. I'm doing a negative times a positive is negative. And then I'm doing a positive times a positive times a positive is positive. Okay. So yeah. All right. Yeah, so that one, once again, I didn't like that last part, like doing by hand was just like not really like practical. It's just yeah. But like what made me think it was negative is that I was like, oh, G of 1 is 0, and then it's decreasing from 1 to 2. So on its way from 2 to 3, it all depends on like maybe I could look at the second derivative, but even second deriving this would be like kind of awful. So I just don't think there's a lot of value in like spending like this much space deriving and analyzing. But it's, you know, possible, but it's like not really like worth, you know, the question, yeah, it was like, I think like a poor design. All right, so here, integral 1 to 4 of this. So I just think of absolute value x. I'm thinking of this. And then I'm moving this. Good, it's all connected. 1, 2, 3. So let's just say that's 3 units. So that puts the vertex here. And I'm going from 1 to 4. That means we're doing this and then this. Okay. Now the trick is like, oh, how high up am I? If I do this in my head, the math that I'm doing is I'm just plugging in x equals 1. I'm doing absolute value of 1 minus 3 is absolute value of negative 2. And that's equal to 2. So this triangle here is a 2 by 2. So I'm doing 1/2 base times height. So then 2 times 2 is 4, divided by 2 is 2. This one is a 1 by 1. So 1 times 1 divided by 2 is 1/2. And now I just add these. This is 2 plus 1/2, which is 5/2. So choice C. All right, use geometry. That one's the way. And yeah, hello to everyone just coming in. Thank you all for being here. And if you wouldn't mind, if you haven't subscribed and this is helpful, like please subscribe. And if you have people in your class that don't know about this and you wouldn't mind, you know, help me spread the word, that would be awesome. Although YouTube's algorithm does a pretty nice job, but I mean, any help I could get, you know, that I do appreciate. All right, so if I just want to check my answer to this, whoops, I just forgot to type something. Okay, I get 2.5, which is this. Yeah, you could find the antiderivative, but like, honestly, I think geometry is the way to go. Another one that happens with is like, they'll say like, quick, what's the integral from 0 to 3 of like radical 9 minus x squared dx? You know, and that's a the integrand is the equation for a semicircle, or expression for a semicircle. So it's just the area of the semicircle from 0 to 3. So then it's pi times radius squared would be a full circle, but just 1/4 of that. So this would be like 9 pi over 4. So you could spend like a long time doing like a trig substitution to anti-derive this, or just geometry. So geometry wins. Yeah, it's all about doing this with the least effort possible. Like this one. Anytime you integrate an odd function. The integral of an odd function, dx from like negative a to a is equal to 0. So like, for example, think of like the integral of x from negative 3 to 3. This, if you just think about it, like negative 3 to 3, the area is equal but opposite. So it cancels out and it's equal to 0. So for this one, there's a nice way to do this. I would break this up into the integral from negative 2 to 2 of x to the 7th, which is an odd function. You could do this by hand, but if you know, like, oh, here's an odd function, then like this whole thing goes to 0, just cancels out. Okay, let me just get rid of that piece. So odd function. Okay. And then I have plus the integral from negative 2 to 2 of k dx is the other piece. This is a constant k. So they're telling us that this sum equals 16. So then I'm going to anti-derive. I have k times x is the antiderivative of k, because the derivative of kx is k. From negative 2 to 2 equals 16. And this is going to give us k times 2 minus negative 2 equals 16. So we get 4k equals 16. And k is equal to 4. All right, so odd function. If you want to anti-derive this and get 0, then you can, but you don't have to. Yeah, don't anti-derive square root of 9 minus x squared. It's like not pleasant. Vin, I'm so cooked. No, hang in there at Arrow. Remember, I'm saying just keep practicing and you'll get there. And you'll be fine. All right. This one, 14 is nice. Oh, anyone who was here yesterday, let me know. Are these questions harder than the ones from yesterday? I think so. Yesterday, I undercooked them. Today, I think I overcooked them a bit. To use that Gen Z lingo. Antiderivative of this. All right, so e to the x plus e to the x. Is equal to the integral of e to the x times the integral of e to the x. So law of exponents from algebra, back when life was easy, is going to give us this. Okay? And from here, like that's what I'm doing, but I'm doing that rule backwards. Because now what this allows us to do is a U-substitution. I'm going to say U equals e to the x. So then du is e to the x dx. And now I'll highlight e to the x dx. I'm going to call this du. And then this piece, let's go green, is where I'm substituting. Okay, so now I'm going to say the integral of this piece, e to the u, and then e to the x dx in yellow, I'm going to call du. So now this is just e to the u plus c, and this makes e to the x plus c. Okay, so e to the x plus c, and that's going to line up with choice E, it looks like. They're not like, they left out the plus c. They said which one is an antiderivative. So that's just one of them. Let's say c equals 0. Yeah, U substitution here all the way. All right. So we're making progress. Wow, we're 1 hour in. I'm on question 15. I got to move a little bit. So more U sub. So U equals x over 2. So 1 minus U squared. They all look almost the same, but what I'm going to say here is if U equals x over 2, I can multiply by 2 on both sides and say 2U is equal to x. So this x on bottom, that's where the 2U is like going to come into play here. Another thing we got to know here is that if 2U equals x, 2du is equal to dx. Okay, so this is important, and this is important. The other thing that's important is we have to find new limits. Okay, so the new limits, u equals x over 2. So I'm going to take the old limit 4, divide by 2, gives me my new limit for u. And then I plug in 2 for x. I get 2 divided by 2. is 1. So now we could transform this thing. This integral, I'll write it over here, is going from 1 to 2. Okay, that's where like these choices are out. The reason why these are no good is they have to say x equals. If you're changing variables but you don't change your limits, you have to say x equals to specify that they're the old limits. Now I have 1 minus x over 2 is u, so I have 1 minus u squared over x is 2u, and dx is 2 du. And notice 2 over 2 cancels. So now this is the integral from 1 to 2 of 1 minus u squared over u du. They don't actually want us to evaluate this. They just want us to set this up. And we're going to get A. If I want to see if the series converges, I'm doing the nth term test. That's the easiest one to check in your head. Okay, then I do P series. That's like the next easiest. Then like alternating series. And then like the ratio, the integral test is like probably my least favorite. Because it takes forever. Like you have to do an improper integral. But when we get to the series, yeah, nth term all the way. Like, because you could do that in your head. Like if you want to show something diverges, like that's the fastest way. But converges, yeah, I would try the others. Alrighty, so here we have the velocity of a particle is this. If at t equals 0, position is 4, then find the function for x of t. So we have x of 0 is 4. Now, position is the antiderivative of velocity. So if I integrate velocity, so this is going to tell me position. Okay, the integral of velocity is position. That's a big idea. So now antiderivative of 2t, so we're going to get 2t squared over 2 is t squared minus 4t plus c. And then I'm using this initial condition, x of 0 gives me 0 minus 0 plus c, which is just c. I'll make that neater. And that's going to equal 4. So then from here, we have the constant is 4. We have x of t equals t squared minus 4t, and then plus 4. So t squared minus 4t plus 4 looks like choice C. An integral converges, improper integrals, which I'm going to cover later. All right. Cool. Oh, could somebody just do me a small favor? If you have a calculator in front of you, because I'm going to check this again at some point. But I guess earlier when I did this on my time off, G of 3, could you do math 9, 1 to 3 of this and tell me that you get something negative here? Because which of the following statements must be true? I just want to verify that G of 3 was negative for sure. I'll do it again, but I think if like one of you type and just say, yeah, it's negative, like it could speed things up. And that way we're all involved here. In class, when I'll give like little tasks like that, and people are like really paying attention. And this group is awesome, by the way. I appreciate you all like keeping it real in the chat, and you're all like engaged. I love seeing the chat go like this. So thank you for helping make this stream good. I think these questions are pretty hard, especially like later on, some of them. But these are like from like College Board stuff they released to the public. So it depends. The practice exams we do in class, I think, are what's it called? Are about on par. There are some really hard questions, but yeah, these, I don't know, maybe I just like selected tough ones because I was like, oh, let's look at more challenging questions. So I'm going to cross multiply here. Y dy equals 4x dx. I want to find the solution here to this differential equation. So I cross multiply to separate variables, and now I could integrate. The antiderivative of y is 1/2 y squared. And now I'm going to set this equal to 4x squared divided by 2 is 2x squared, and then plus c. So now y of 2 is negative 2. So this is our x and our y initial condition. So I have 1/2 negative 2 squared equals 2 times 2 squared plus c. So this is going to give us half of 4 is 2 equals 8 plus c. So c is negative 6. And now we could plug this into our general solution here. And we're going to have 1/2 y squared equals 2x squared minus 6. And now just solve for y. Okay, this one has a nice trap to it though. So I multiply everything by 2 and I get y squared equals 4x squared minus 12. So I can already see like it's looking like one of these. But now I take the square root. Almost everybody just says y equals radical this. And now I call it the bear trap, all right? And if I was at school, I would have a bear roar at everybody right now. So this is a bear trap because you have a decision to make, plus or minus. In this case, we're actually going to choose the minus. And why? Because the initial condition here has to be satisfied. When we plug in x equals 2, we have to get y equals negative 2. And we're not going to get a negative out of a square root, so that's why we went with the minus. Okay, so it has to be this one, choice C. Okay, so 17, yep, should be choice C, and I'll just, yep, this is looking good. Cool. So remember, has to satisfy the initial condition. This is very important. All right, next, what if we have something like this? So trig equations. So dy dx equals y, and then secant squared x. So this one, I would multiply by dx on both sides and divide by y on both sides. So y over y, see you later. Dx over dx, see you later. And we got dy over y is secant squared x dx. And now we integrate. Oh, thank you for checking. Negative 1 point. All right, I appreciate that. I got the same thing, I believe, when I did that before. Oh, it's in the history, maybe. Cool. Thank you. Oh, I appreciate that vote of confidence. I do my best. I take this job seriously. I really and I'm each year trying more and more to just try to understand the students a little bit better each year. I really want to help people get this because I think it's very satisfying when it clicks. Because a lot of people, they do tap out because it's a lot to ask of people. Like, hey, just like learn this like really crazy thing. Like, just do these like 48 steps of math and you'll be golden. Like, that's not easy, especially when you got to keep getting it wrong over and over and over until you're able to fly. So, I had to pay my dues, and I just want people to see like, yeah, no, you'll get to that level. There's a lot of levels to this, and it just takes like, persistence, and you'll get there. So, all right, let's see. So we have, this is our general solution. So now I'm going to plug in x is 0 and y is 5. So I have natural log absolute value 5 equals tangent of 0 plus c. Tangent of 0 is 0. So c is equal to just natural log 5. Okay, the absolute value of 5 is 5. So I could just drop the absolute value. Now the fact that the absolute value just dropped tells us we're going to say natural log of y equals tangent x plus c, and c is ln 5. And now watch what happens. People go, all right, solve for y. So they exponentiate both sides, and they're like this. And then like y equals, cool. They're like, oh no, my answer's not there. Math is not fair. I don't like math. But no, all you got to do is just be a little patient. So this rule, we're using this rule, but backwards. So I'm going to rewrite this as e to the ln 5 times e to the tangent x. Okay, so this is a separate line. I'm rewriting it. Because you could see I would have e to the ln 5 plus tangent x. But now e and ln are opposites. So this becomes y equals 5e to the tangent x. All right, which is choice C. Cool. All right. So let's see here. Moving on. Slope fields. Everybody's favorite. All right, these are a slippery slope. So for this one, I look for patterns. If you took pre-calc, And like the running joke is that pre-calc is like kind of useless and it doesn't prepare you for this at all. I wouldn't say it's useless. Like there's some cool parts of pre-calc, but there's like hyperbolas and ellipses, and I want to say this one might be a hyperbola. Okay, yeah, 19 is like hyperbola territory. I just want to. Oh yeah, this was the question where it's yeah like hyperbola. So hyperbolic is like kind of like this. All right, ellipse is this, and then yeah, like circles. So there's like a few different ones, but like I don't know, pre-calc, like that's the way to go. You could just play the process of elimination game too. So what I'm seeing here is I'm like, oh, if y equals 0, dy dx is undefined. And now I'm going to draw somebody that might traumatize some of you, slope guy. Okay. So slope guy, I show this to geometry kids too. When you have a positive slope, your line goes up. Negative slope, your line goes down. Vertical line, the slope is undefined. And then a horizontal line is a 0 slope. So slope guys knows here. So I'm looking for vertical tangents. Okay, specifically when y is equal to 0. And there's 4 to choose from here. So looking at this, I could see y equals 0 makes me think of the x-axis. Y equals 0 is here. So what I'm looking for is along the y-axis, I want to see a bunch of vertical slopes like this. Okay, so, or like undefined slopes, like vertical tangents, I should say. So you see choice E is the one. Choice E, you could see at this location here that we have all of these vertical slopes happening. Okay, like these are starting to head this way. So the reason why the others are no good, let's go through the others. So we might see here, how about x and y are positive? You could play that game. Like you just plug in a value here. Like let's say like, oh, I plug in 2, 2. If I plug in 2, 2 to my derivative, I'm going to call it y prime. I'm going to get 2 divided by 2 is equal to 1. So this, notice the slope is negative. So I'm like, all right, you're out. And then in this neighborhood, the slope should be 1. And it doesn't look like it here. So like this one's out. This one here, another thing I could point out like is the vertical slope. I'm sorry, the vertical tangent. I guess I'm saying vertical slope because it's undefined. But that's one thing to look for, which is telling me like kind of like right away, this is it. Another thing to look for though, is that when y is equal to x, if y and x are equal, y prime, the slope is equal to 1. And a slope of 1 looks like this. So that means like along the diagonal, I need a slope of 1. And you see here, I have a slope of 0. So this is not it. Along this diagonal, y equals x, I need a bunch of 1 slopes, and I don't have that here either. Along the diagonal, y equals x, I need a bunch of 1 slopes, don't have it either. Okay, and then same thing here. Along this, I need a slope of 1, I don't have it. But here, I'm going to zoom in, just in case people didn't bring their microscopes. And you could see that along the diagonal, we have our slopes of 1. Okay, so this has really got it happening. All right, cool. Very nice. All right, so let me just see. Okay. All right, so question 20, we have another slope field. This one, honestly, we just sketched the solution through the slope field, and it looks like this. And now it doesn't look like x squared. It doesn't look like, yeah, x squared, I'm thinking of this. E to the x, I'm thinking of this. E to the negative x, I'm thinking of this. Cosine x, I'm thinking of this. Natural log x looks like this. I'm like, all right, choice E right away. What else looks like it's happening is that at x equals 0, we're getting those undefined slopes again. Okay, so at x equals 0, the slope, I could say dy dx, is undefined. However, if I derive all of these, y prime for a is 2x. And if I plug in 0, yeah, that's defined. That's not a problem. So this is out. If I derive this, if I plug in x equals 0, I get 1. And these don't look like 1 slopes. Same idea for this one, except I get negative e to the negative x. I use chain rule. So at x equals 0, I get a slope of negative 1, which doesn't seem to be the case. Y prime for choice D is negative sine x. I should get a bunch of 0 slopes, and I'm not. And now here's the culprit. Y prime for ln x is 1 over x. And here, if x is 0, there's that vertical slope. Okay, the vertical tangent. All right, and this is the last slope field. So this one, another trick is to look for, like, which of the following, like this is a slope field for which of the following differential equations. I like to look for a line of zeros. So this one here makes me think when y is plus or minus 2, we have the slope dy dx is equal to 0. And now I think back to like the algebra days. I'm like, oh, if I have a factor of y plus 2 times y minus 2, that's going to give me roots of plus or minus 2. Okay, so I just kind of anticipate that like y prime or dy dx is going to have this. So y prime is going to be somewhere in the form of like y squared minus 4. And the only one that has a y squared minus 4 is this one. And you could even see if y is plus or minus 2, dy dx is 0. The other ones, that doesn't happen. So choice B. All right, so slope fields. All right, moving on to unit 8. So to unit 8. And then once we get to like question 30-ish, it's going to change up. Cool. How long have I been teaching? 11 years. This is my 11th year as a teacher. So cool. Yeah, it's I've been teaching for quite a while. Oh, let me just see. Oh, there's the chat is going here. Let me read up. Oh, just talking about calculators and all that. Cool, cool, cool. All right. So let's see. We're almost at the halfway point. So if I set these equations equal to each other, 5x minus x squared is this parabola, and then the line is 2x. You can subtract 2x on both sides, and you get here. And you take out an x. And this is going to tell you that the graphs intersect at 0 and 3. Okay, so this is at 0, and this is over here at 3. So the area of the shaded region, the concept is cross sections. That's how I like to show it. That when you're finding area, I like to use the analogy of Ant-Man and the Wasp. Like you take one of those cross sections, Ant-Man and the Wasp means like you're like on that infinitesimal level. Like this is like infinitely thin, this rectangle. So I call this dx because that's like a small change in the horizontal direction. Oh, what did I do before teaching? I was a student. I mean, I started teaching when I was 25. I did construction for a little while. But I basically like was like a math tutor. After I graduated, I did construction briefly, and then I got into teaching. So yeah, I thought about being an actuary at one point in college, but then I tried the major out very, shortly, and I wasn't like, I didn't really, it wasn't for me. Like I liked theoretical math, like the proof-based math. Like, I just didn't know what I wanted to do. So I was like, you know what, let me be an actuary, because then at least I'll be rich. Because that was my thinking at 20 years old. It was like, if you don't know what you want to do, like go for money. But then like I realized I missed taking the math classes that I started with, like the theory-based ones. So I switched back to like pure math, where I was like, that was like where I was like more passionate. So yeah, but I was like basically a teacher from like early on. All right, so the distance between these two is 3, but I could just say top minus bottom. So that's the concept I want to use here. The top function is the parabola, is 5x minus x squared. And the bottom function is is 2x, so I'm going to subtract 2x. So I'm doing the top minus the bottom. Okay, so then here, this is going to simplify to 3x minus x squared. So the area of one of these cross sections, so the area I'm calling dA, this is a slice of the area, is base times height is 3x minus x squared times dx. That's the area of one slice. I want the area of the whole thing. So then I integrate from 0 to 3. And this tells us the area equals anti-derive. I get 3/2 x squared minus 1/3 x3 from 0 to 3. And now just plug in, and we get to plug in 0. So like we'll just say like plug in and then like a minus 0. So we have 3/2 times 3 squared is 9 minus 1/3 of 3 to the 3rd power is 27. So now this simplifies to 27 over 2 minus 27 over 3 is 9. And 9 I'm going to call 18 divided by 2. And now this makes 9/2, which is an answer. Okay, 22 is B. I need to drink some water. Yeah. Just saying yeah at the top minus bottom from the chat. And did I spill water? No, I'm good. All right. Sorry, talking all day at school and then live streaming 3 hours yesterday and today live streaming. It's like, I guess my voice is like giving out a little. I'm just, yeah, doubling down. But you are all worth the effort, okay? So we're going to get through this. All right, the area bounded by this, the x-axis, y-axis, and this line is equal to. So e to the 2x looks like that. So that's e to the 2x. And then we have the x-axis, the y-axis, and x equals 2. So we're finding this area. So this is just the integral of e to the 2x from 0 to 2. Because this was the line x equals 2. And the y-axis is the line x equals 0. So 0 to 2. And now just anti-derive. This formula is good to know. The integral of e to the kx, where k is constant, is 1 over k e to the kx plus c. Okay, so this is 1/2 e to the 2x from 0 to 2. So this would be 1/2, and then e to the 2 times 2 is e to the 4 minus e to the 0. So this makes e to the 4 over 2, because I'm doing times 1/2, minus 1 over 2. I'm just, anticipating that this matches this here. Okay, so then we distribute that half. All right. Oh, for AP World. Yeah, well, there's that, what's his name? Heimler's History. I mean, he's pretty popular, like any AP teacher, especially like ones on YouTube, like know about. Like he's probably the most popular AP World, AP US, AP Euro guy. So yeah, good luck though studying for your other AP test. All right, let's see. Number of bacteria in a culture is growing at a rate of this many, like this, per unit of time t. At t equals 0, the number of bacteria. So I'll just say like P of t. Actually, how about B of t for bacteria at time t? So we'll say like y equals B of t. And this is the amount of bacteria. So here, B of 0 is 7,500. And they're telling us B prime basically is 3,000 e to the 2t over 5. So just say this phrase to yourself a few times. The integral of the rate is the net change of the function. Integral of the rate tells you the net change. So if you want to find the number of bacteria present at t equals 5, we want to know how much does it change. Well, B of 5, I'll call it, is the starting value, 7,500, plus the integral from 0 to 5 of the rate b prime, this. Because when I integrate this here from 0 to 5, it's telling me how much b of t changes from 0 to 5. So that's why I'm doing it. But I have to add it to b of 0. So now let me just move all this over, because I think this question here is intended to be done by hand. All right, and bless you to whoever sneezed. All right, I think my wife sneezed. Okay, so b of 5 equals 7,500 plus, and now I'm going to anti-derive this, because I think this was intended to be a no calculator question. Oh, this is not a specific year. I just took like a bunch of random stuff and I just chopped it up and sprinkled it all together. So it goes from like 1967 to like, I don't know, the like 2018 course description, multiple choice questions at the end. So it's a mix. All right. So here I anti-derive this. And remember that I just said this before. I'm using this again. I'm using that formula. So this, when I anti-derive, I'm going to have 3,000. And I have e to the 2t over 5. But my constant here is 2 over 5. So I could divide by 2 over 5 or just multiply by 5 over 2. And I'm going from 0 to 5. Okay, so that's what's happening here. 3,000 divided by 2 is 1,500. And then 1,500 times 5 is 7,500. So this is 7,500 plus 7,500 e to the 2t over 5. This part going from 0 to 5. So then this is 7,500 plus 7,500 times e. I'm going to leave the constant on the outside. 2 times 5 is 10. Divided by 5 is 2. Minus e to the 0, which is 1. Okay, so this is going to make 7,500 plus 7,500 e to the 2. But this is 1. So when I do 7,500 times minus 1, I get minus 7,500. Now this cancels. It's just 7,500 e squared. So, tricky question. Oh, which question at Mini is more confusing that you want me to explain? You can just say it in the chat. Which one is, yeah, like that you want me to explain. All right, so just write the number and I'll say some more about it. 25. All right, this one, there's a nice way to do it. Don't use sub this. You're not going to get anywhere. So the trick here is algebra. You have to know this. Square root of x squared is not x, it's absolute value x. Okay, so this, this one, 24. So, all right, this one, big idea. Integral of the rate tells you the net change. So like the integral of the rate, I'll call that like b prime, tells you the net change of b, like this. If you wanted to, so at Mini, if I say something a little bit different here, is let's say I'm going to shrink this down. Okay, so I'm just group all this, and then I'll shrink it. Okay, so maybe this will make more sense. So fundamental theorem of calculus. If I say integral of b prime, and I want to know what's happening at 5, and I know what's happening at 0, are you okay with saying you anti-derive b prime, you get b of 5 minus b of 0? But then the goal is to find b of 5. So I add b of 0 to both sides, and you see how that brings me here. Okay, so that's how you want to think about it. This one, you could also say the number of bacteria. You could call it like dB over dt. You could treat it as a differential equation. you could say dB over dt is 3000 e to the 2t over 5. And then here you could do separation of variables and say dB is 300 e to the 2t over 5 dt. And then you could integrate and then just say like, oh, capital B is the number of bacteria equals da 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 plus C. And you could use the initial condition here and you could turn this into like unit 7. Okay, so at Mini, did that make more sense? Hope that does. Oh, why didn't we use integration by parts for 24? Because there's no x there. Like if it's just like e to the 2x, this is just 1/2 e to the 2x plus c. If it's integral of like x e to the 2x, then I have to do integration by parts, and that's for the BC people. Okay, which I'll cover later on. All right, so you need that x in front. All right, so this one, you ready? This is a nice technique coming up. So I'm going to factor this. This is x minus 1 times x minus 1. Because -1 plus -1 is -2, and the product makes 1. So that makes -1 squared on the inside, x minus 1 squared. And now this, remember what I said, the square root of x squared is absolute value x? This is the integral from 0 to 1 of absolute value x minus 1. So this was like sneaky algebra. And now I look at the parent function, absolute value x. I move it over 1. And let me actually, do it like this. Let me just scale it up more so that we could actually see it. So now integral from 0 to 1 is this triangle here. This is a 1 by 1 triangle, so it's 1/2 1 times 1, which is a half. Okay? So make it easy for yourself. Yep, I got a half. All right, more than halfway. Somehow we did it. So this, let's just see. Position is s of t. For what values of t is speed increasing? So speed increasing is when v, velocity, and acceleration have the same sign. Okay, so just remember that. I'm going to make 2 sign charts. So here, I'm going to make a sign chart for v of t, the derivative of s of t. So I have the derivative is 6t squared minus 48t, and then we have plus 90. Okay, now this, I'm going to set equal to 0. So I take out a 6. I have t squared minus 8t. And that's going to go in 15 times. Yeah, 15. Set it equal to 0. And that's t minus 3 times t minus 5. So we get t equals 3, t equals 5. And now we will, in a moment, make, actually, no, I'll just make the sign chart now. So velocity, greater than 0. So we'll say 0 is here. So 3 and 5. And remember what I said before. This is a smiling parabola. So it looks like this. So if the roots are 3 and 5, like here and here, then it goes plus, minus, plus velocity. That's plus, minus, plus. Okay? I'm going to show you a really cool way to do this after, if you don't like this way. And then a of t is the derivative of v of t. Acceleration is derivative of velocity. Is 12t minus 48. And now 12t minus 48 equals 0 when t is equal to 4. And if I made a sign chart for acceleration, and I'm starting it at 0, if I plug in 1, 12 minus 48 is negative. If I plug in 5, I get a positive. So it goes minus plus. So here what you could do is you could make a super sign chart. So you put all of the significant values. I put 3, 4, and 5 down. Okay, so I put these all down. And if I go this way, let's see what happens. So from 0 to 3, velocity is positive. I'm just going to say, yeah, 0 to 3, velocity is positive. And let me switch colors here so it matches the velocity sign chart. So positive. From 3 to 5, velocity is negative. And from 5 to infinity, velocity is positive. And then in purple, we had acceleration is negative before we get to 4. And then positive after 4. So we're looking for, where does velocity and acceleration have the same sign? Here and here. So from 3 to 4 and from 5 to infinity. That's why it's choice E. Okay? Cool. All right, let's see. Head out. Oh, yeah. I'm happy to help. And I appreciate that, Andrew. Yeah, so yeah, get some rest, and thank you. I really mean it for stopping by. It does mean a lot to me, like, you all being here and supporting this. 50 people here, like, this is truly awesome. We had 432 total already. Like, this is like, yeah, it's just like awesome. So thank you for being a part of this, like all of you. But another way to do this, velocity, if you take the absolute value of velocity, the absolute value of velocity is speed. Okay, so this, you could actually do it another way. This is not hard to sketch. If I sketch this, I have roots at 3 and 5. Looks like this, like it's a parabola, it's going down and then up. However, if I have absolute value, it's going to take the negative stuff and flip it up. Okay, so speed would go like this. Like, let's say I say speed is going to be in purple. So speed, I would take this and this part, let me just draw it neater, goes up. It reflects the negative over. That's what absolute value does to a function. Like, you ever think about like absolute value x? Think of like y equals x. Looks like this. Just draw that neat. And the absolute value, like if I do this, it takes the negative stuff and it flips it up. It makes the V shape. Okay, so absolute value takes the negative and flips it over. And now you just eyeball it. You could say, all right, well, let's say 4 is over here. The graph is increasing from 3 to 4 and from 5 to infinity. So then you don't even have to do all this sign chart stuff. That way is the coolest. All right. So moving on. What is question 27? So question 27, we want to know the total distance traveled by the particle from 0 to 2, and we get velocity. So total distance for Calc AB is integral of speed. It's the same formula for parametric for BC, but the Calc AB version is just like moving on a single line. It can't go like up, down, left, right. So it's just this. And we're going from 0 to 2. So this one you just type in the calculator. We'll do that. So let's see, second quit. And math 9, 0 to 2. We are in radians. Don't be in degrees. That'll ruin your test. Okay, and then math, go to the right, absolute value. And the velocity function is 3e to the negative x over 2. Instead of t, I'll use x. And then we get sine of 2t. Throw in the dx. And 2.261. Choice D. Okay, so here it is. And let's fix this up. All right, that's good enough. Cool. So this one should be, yeah, choice D. So knowing your formulas, like the calculator questions are nice because, yeah, like you just have to know the formula and just not make a typo. So it's pretty awesome. All right, this one. Oof. What is the volume revolving? All right, this one, let's pretend no calculator. So here, I have y equals 2x. We'll say y equals 2x. It's here. And then 2x squared. Now, 0, 1, 0, 1, 0, 2. I would just set these equal to see which one it is. So this, I could say 2x squared minus 2x is 0. And then 2x times x minus 1 is 0. So x is 0 and 1. Okay, so those are going to be the intersection points of y equals 2x and the parabola. Okay, so parabola coming in like this. And you know what, I'll draw it like a little here like this. So 0 and 1 is happening at 1. Okay, so we're focusing like on this space here. And that's the region we're going to revolve about y equals 3. So these intersect at 1, 2. If I plug in x equals 1, I get 2. So y equals 3, the line that we're going around, is here. Okay, so this is what we need. All right. Now, whoops. I was going to pull up a fun thing of a yeah, you know what though, I don't have the time. I was going to pull up a GIF image or a short video of like a chicken spinning. That's how I showed in my class, but yeah, I just imagine the chicken. So here, when I spin this, notice there's a gap here. Okay, this tells us we have a decision to make. And let me change colors here. So I'll go with pink. That I have a space here. So my cross section is going to be the washer. Okay, there's a gap. Okay, here's our gap. And since we're revolving about a horizontal axis, we're going to go dx. And we need our outer radius and our inner radius. Just know the radius goes to the axis of revolution. So this, think of as your center. Okay, like the, whoops, I don't know what just happened there. But this is the center. So I just imagine like this is like where our axis is going through. It's like spinning on this, the cross section. Okay. So here, top minus bottom, this is the line y equals 3. So my outer radius is going to go from here all the way to here. It's going to go this big distance. So it's going to go 3 minus all the way to the red. And the red here was y equals 2x squared. Okay, so that's my outside radius. My inside radius is going to go from here to here, but vertical distance, I'm doing top minus bottom. So I'm doing 3 minus 2x. And now the volume of one of these slices, remember, is dv. And then it's like the, think of these as like cylinders. It's like pi big radius squared minus pi little radius squared. So I have pi outer radius squared minus pi inner radius squared, which gives us this formula. And it's dx or dy, but in this case, we're going with dx because we're spinning this way. All right, so then that's the volume of one slice. We're going from 0 to 1. So then here, we just go 0 to 1. All right, so this tells us the volume is pi integral 0 to 1. And then we have outer radius squared, so 3 minus 2x squared minus, let me fix that. Outer radius was 2x squared squared. 3 minus 2x squared squared. Yeah, I got to write that. Minus, let me move this over. And now, I'm just plugging in. So minus inner radius is 3 minus just 2x squared and then dx. Okay, so 28, we scan, should match this. 3 minus 2x squared squared minus 3 minus 2x squared. Oh, okay. Need assistance on when to use dx or dy. So here, what I imagine is it's spinning this way. It's spinning in this direction. So this, you see how I drew a vertical line like this? So the distance here is a function of x. Because, like if you have a point in space here, you go over x, and I'll change colors. So you go over x and you go up y. But remember, y equals a function of x. So when I'm describing this distance, I'm describing it with functions of x. So that's why I need the dx, because I need a function of x and then dx. So when you have vertical cross sections, then you have function of x, so you need dx. And another reason is that, like, when I take this cross section here, the little distance going this way is a small change in the horizontal direction. So that's what like dx models, is like a small change this way. Okay, so yeah. The reason why it's not this one is you just did this thing squared minus this thing squared. But we're not spinning around the origin. We're not spinning around the x-axis, which I would even have to double check. Yeah, that would be if you were spinning around the x-axis. So if you got C, you revolved around y equals 0. Okay, if you revolve around this line, then, like if you look here, if I go around the line y equals 0, the x-axis, then my outer radius is 2x, and my inner radius is 2x squared. And then you see outer radius squared would be 2x times 2x is 4x squared. And then 2x squared times 2x squared is 4x to the fourth. So that's why. Yeah. All right, so moving on. All right, so now what happens if we go this way, horizontal? So we have x equals e to the y. I got a little smushed. We'll say x equals e to the y, which if you natural log both sides, and let me just see, natural log both sides gives you y equals ln x. So when I sketch this, I could just draw ln x. Okay, and what we're doing is the region bounded by this, x equals 10, let's say, is out here. And then y equals 1 and y equals 2. So maybe it looks something like this. Okay, and we're finding that area. So for this one, we want to find horizontal cross sections. That's the easiest way to do this. So then here, what I'm going to do is I have to name this as x equals 10. And then this curve, which maybe I'll make green. This is natural log x, but I could also just call it x equals e to the y. So then when we describe this cross section, let's say I just call this in this color, x equals 10. When I describe one of these cross sections here, it's the thing on the right minus the thing on the left. So I'm going to do 10 minus e to the y. And that small change in the vertical direction now is dy. So now I could say the area of this is base times height is 10 minus e to the y times dy. And now just integrate from 1 to 2, from the bottom to the top. So it's integral 1 to 2, 10 minus e to the y dy, looking like choice C. Okay. Last Calc AB question, and then the last 20 are BC. All right. So here, honey is poured through a funnel at this rate. And how many ounces of honey are poured through the funnel from 0 to 3? So this one, we're integrating from 0 to 3, r of t dt. Okay. How I know is that this is ounces per minute, and dt is in minutes. When these cancel, it makes ounces. So just calculator this. Okay. So math 9, 0 to 3, and we have r of t in there. So all right, 7.429. So 7.429. Just math 9. Cool. All right, BC. So AB people, you could stick around, but if you don't, I don't take it personally. But now it's BC time. Cool. This though, honestly, if it's free response notation is very important. I'm going to say limit as b goes to infinity, integral from 2 to b of dx over x squared. Then I got to do this notation. But multiple choice, who cares? Multiple choice, you could have the worst notation in the world. It only matters what you bubble. So 2 to infinity, x to the negative 2 dx. I anti-derive, divide by negative 1. I'm going from 2 to infinity. And now this, I just call negative 1 on the outside. And now infinity to the negative 1 is 1 over infinity. Minus 2 to the negative 1 is 1 over 2. 1 over infinity goes to 0. I always use the analogy, pretend it's your birthday. You have one pizza. So happy birthday, here's your pizza. Okay, maybe you have 8 slices. But the catch is, there's infinity people at your birthday party. 10 trillion people show up and you got to share the pizza. So now you're sad because all your pizza goes away. You all get nothing. Negative 1 times negative half is positive half. So choice A. Let me just take a quick water break. All right, we are 3/5 of the way through. Moving on. All right, this one, arc length, but f of x style. So you got to know this formula. Integral a to b, 1 plus f prime of x, or dy dx squared. That's the one. Okay? And that's when you have like some curve from a to b. And you want to know the arc length. Okay, so like this is the length of the curve. So here, if this is your equation, y equals dy dx, chain rule, derivative of the outside is cosine, keep the inside, times, think of that as x to the half, and you get 1/2 x to the negative half. So this I could just say is cosine radical x over 2 radical x. Please don't even think about doing that. All right, don't cancel those out. This is part of the function, so we can't just do that. All right, now we plug in. So from here, we have the length of the curve, call it L, is integral from a to b. They didn't give us actual values. Square root of 1 plus, and now I square this. So cosine radical x times cosine radical x is cosine squared radical x. Remember, the argument of cosine does not get squared. It's just cosine squared of radical x. All right. Good luck on your AP exams. A push, macro. Yeah, good luck A push and macro people. This is BC. So now it's BC only. BC for the rest of the test. Okay, this is also BC. So BC, improper integral. So the problem with this one, what's the problem here? Is at x equals 1, like if I call this like f of x equals 1 over 1 minus x squared in parentheses, f of 1 is undefined. Okay, so specifically, like if I think about what this looks like. So here's x equals 1. Shout out to like one of my, team teachers or, coworkers. They call this the volcano function. I hadn't heard it until I heard the teacher call it a volcano function, but it looks like this. And there's a vertical asymptote at x equals 1, and we're integrating from 0 to 3. So from 0 to 3, it's like we have to go through the vertical asymptote. So the $1 million question here is, does the area get to the asymptote fast enough, or does it spill out to infinity? Does it diverge? So here, this type of improper integral, we would want to go from 0 to 1 And you know what? Let me write it like this. We're doing this, and then plus 1 to 3. Okay, so if it's possible, we have to do it one by one. The problem is here. Okay, now I want you to think about from 0 to 1, you're on this space. We are approaching 1 from the left side. So this piece I'll handle first. I'm going to do the limit as b approaches 1 on the left. Integral 0 to b. Okay, I'm going to use that notation. Okay, so instead of going to 1, I'm going to use b, and I'm going to get close to 1 from the left and see where am I headed. Okay, so here, 1 minus x. Oh, thank you, Etnanoa. I appreciate you so much. A tip. Yeah, thank you. It's so cool the way they light them up too and all that, but I appreciate you. Thank you so much. It's yeah, I'm happy to do this for everybody, but yeah, the super thanks are much appreciated. All right. So let's see. 1 minus x to the negative 2 dx. So here we have the limit as b goes to 1 on the left. And now the antiderivative of 1 minus x to the negative 2 is 1 minus x to the negative 1. Then I divide by negative 1. I get a negative, but I could do a u-sub, but for these questions, I really don't want a u-sub. The derivative of the inside is negative 1. So then I divide by negative 1 again, and I get this to be a plus. Okay, so that gets rid of it. If you want to check that you anti-derived correctly, now, actually, no, let me keep this here. I'll get rid of this. If you're like, wait, is that definitely right? Am I sure? I would derive this and see what happens. So this is negative 1 times 1 minus x to the negative 2, but the derivative of the inside is negative 1, and you see it makes positive 1 minus x to the negative 2. So this is good. And we're going from 0 to b. Okay, so now I work this out little by little. Okay, I have 1 minus b to the negative 1 is 1 over 1 minus b. Minus, I plug in 0, and I get 1 to the negative 1 is 1. And now this, the limit as b approaches 1 from the left side. So what I imagine here is something like 0. So 0.0. I'm sorry. If I'm approaching 1 from the left, I think of like 0.999 like this. So just this. Let's say I just do like 3 nines. If I do 1 over 1 minus this, that's 1 over 0.001. This starts to go like towards infinity. As I get closer to 1 on the left, this goes to infinity, so it diverges. And if one piece diverges, the whole thing is divergent. Okay? So that's it. All right. Yeah, that one's a little tricky. You could also just think of like 1 over 1 minus x is yeah, going to have a vertical asymptote at 1. So it's going to be like a, situation where like it's infinite. Alrighty. So yeah, that's why it's going to infinity. All right, logistic differential equations. So let's just see here. I'm just trying to follow the chat. Blah, 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 blah. Oh, can I go over second order derivatives really quick? Second order derivatives is, let me just see. So are you talking about like concavity and all that? So just say, yeah, say more, a little more in the chat. Are we talking about like concavity? Because, let's see, like f prime greater than 0, concave up. Yeah, if you're successful with these questions, I would say like you're like definitely on like a good track. These are like not easy ones today. Yesterday, some people were saying like, "Oh, I think it was like maybe too easy the questions." So, um, I mean, there were some at the end I think that were definitely tricky. But second order derivatives just really is asking you like to determine concavity. So what I do is I just make a sign chart for f double prime. And if it's positive, I know my curve is concave up there. If it's negative, I know my curve is concave down there. So if I had something like, let's say, x squared, I look at this. So x squared, I know is always concave up because it's always smiling at us, right? But if I derive this twice, I get 2x, and then I get 2x, and then I get 2. So I'm like, oh, this is always greater than 0 for all x, so that's why my curve is always concave up. Yeah, BC, I mean, BC is definitely a bit harder. Like, it's more abstract. Not that AB is easy. I mean, Unit 8 is tough, you know, regardless. But, yeah, that's like, yeah, like Maclaurin Taylor is going to get a little tough. All right, so here, the concept when you hear logistic is you're thinking of this. Okay, so it's something like that. But the trend here, and let me draw this again, is as t goes to infinity. So let's say this is t, and this is the function f. So based on this differential equation, we could say like, oh, this is what it looks like. But as t goes to infinity, we call this the carrying capacity. F goes to L. But df dt, the derivative, the slope is heading to 0. See, it's like flattening out as it goes up. So here, what I like to do is I just set this df dt, I set it equal to 0. And f equals 0 is just this part. Like, that's the boring asymptote. I don't know if I should call it boring, but it doesn't help us answer this. This is hitting at 2000. So here, what I do is I set 1 minus f over 2000 equal to 0. And then I'm like, oh, that would be when f is, I'm sorry, 5000. Why did I write 2? I guess I had 2000 on my mind. Yeah, I'm setting the inside equal to 0. This is true when f is 5000. So the carrying capacity at the top is 5000. That's here. So the limit as t goes to infinity is 5000. Other questions they could ask you is like, when is the growth rate maximum? The growth rate is maximum at the halfway point, so at 2500. So this is max growth. And that's also the point of inflection. Okay, it's the point of inflection because that's where the graph switches from concave up to concave down. Okay, so at Nanoa from before, when you were asking about second order, it's supported here. Okay, if you were to derive this, you would see that from 0 to 2500, f from 0 to 2500 is going to give you concave up. From 2500 to 5000 is concave down. Yes, max growth is halfway through carrying capacity. The whole idea with these questions is like not to actually do this by hand, right? What they don't want you to do, I'm going to tell you this, please don't, because you're going to lose all the time. Unless they ask you, but don't do this. Don't go like, oh, df over 0.04f times 1 minus f over 5000 equals dt. Like, please don't do something like this and then like, cool, partial fraction. Like, no, that's going to take too much time. You can do it if you want, like, but like you're going to like basically just run out of time. So they want you to just use the properties of the graph. That's the really big, ideas that you want to use here. All right. So this one is done. Euler's method. All right, Euler's method is concept. So we'll talk about the concept here first. Is I have some curve, and I want to, let's say this is like my starting point. So I'm going like this. Wait, I'm going here like this. Let me just try to make this go as nice as possible. So calc AB is like, oh, all right, I want to approximate, like, let's say this is 2 and this is 4. And we're like, hey, I want to approximate this value of the function. You would plug 4 into your tangent line. But in BC, what happens is like you make another tangent line. So I plug this point in red into the derivative, like the x value, and I'm like, oh, the slope changes. And you write I'll just try to make it like parallel, and then I'll move it. So I make another tangent line here. And notice that if I plug into this one, instead, the second tangent line, my approximation is closer to the actual. So this is like actual. And then these are approximations. So that one just gets you closer. So that's the idea, is we write the equation of two tangent lines. So let's see. Blah, 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 blah. If this equals this. So we're starting at g of -1. G of -1, they told us, is equal to 2. It's just a coincidence that g prime at -1 is 2. But this is like starting at the point -1, 2. Okay, so, all right. And we're using a step size of 1.5. So we're going basically from -1 plus 1.5 would give us 0.5 here. So like these are the three significant locations. So now I have g prime of -1 is also 2. This is my slope. And this is my point. Okay, think of this as like your x1, y1. And now you're going to have y equals, I have slope 2, x minus -1 becomes x plus 1. And think of this as like y minus 2. When I solve for y, I do plus 2. But now this is like starting at x equals -1. So now I plug in x equals 0.5. Would give y equals 2 times, and then I have 1.5, and then plus 2. Okay, so yeah, this is bringing me to, oh, I'm sorry, 1 minute here. This was -2. I wrote +2. I'm just making sure. Yeah, so I just transcribed, like I should have wrote -2 here. So yeah, I thought it was funny that they were matching. I can't see the chat right now. Some people probably like, no, don't do it. So yeah, g of -1 is -2. So when I use the equation of the line, that's going to change this to a minus. That's all. All right, I'll write it from scratch. So here, we're going to have y minus y1 equals slope times x minus -2. Okay, I'm sorry, x minus -1 becomes x, plus 1, like this. So I have 2 times x plus 1 and then minus 2. All right, so that's our tangent line. So now just make the adjustment. Okay, cool, so minus 2. So this is going to give us 3 minus 2, which is equal to 1. So then what we're doing is we're using the new point here, 0.5, comma 1. Okay, so this is like kind of like this point over here, where we're going to write our next tangent line, like, go up. So now here, I have to know what's my new slope. Well, g prime of 0.5 is equal to 1. I'm just using this value here in the table. So now I have the slope is 1 times x minus 0.5. And I have y minus 1 equals. So I'm going to do plus 1 on both sides to get here. And now finally, I want to approximate g of 2. I could say g of 2 is roughly equal to 1 times 2 minus 0.5 is 1.5. And then plus 1. So this one here should work out to 2.5, and it does. 2.5 is choice D. All right. Oh, what math did I take up to? I was a math major at Nick. So I took up to like real analysis, graph theory, combinatorics, complex analysis. Real analysis was hard. That's like the proofs behind calculus, like proving all the theorems and all that. Like it gets very abstract, very dense. But yeah, I was a math major. Graduated in 2011, so long time ago. All right, Unit 9, parametric. Tangent line in the parametric world. So for parametric equations, they could be all funny looking. Like they could do stuff like this. All right, but any point we could just say is like, oh, x of t, comma, y of t. So here, like our xy, I get by plugging in the time. So here at t equals 1, I have, like x of 1 is equal to 1 squared plus 2 times 1, which is 3. Y of 1 would be 1 to the third plus 1 squared, which gives me 1 plus 1. First day of school is 2. So my point is 3, 2. Derivatives in parametric, dy dx is dy dt over dx dt. So that's what I'm going to find here. Dy dx is, I derive my y equation. I get 3t squared plus 2t. Over the derivative of my x equation is 2t plus 2. So then dy dx, I want to know, like, what is the slope at t equals 1? I just plug in 1. And now I'm going to get 3 times 1 squared plus 2 times 1, 3 plus 2, over 2 plus 2. Because when I plug in 1, it just gives me the coefficient. Whoops, I hit the wrong button. Okay. So 2 plus 2 is going to give us 5 over 4. So now tangent line. So here's my slope. And here's my point. So I'm going to have, we'll change colors. 5/4 is my slope. X minus 3. And then y minus 2 equals. So right away, I want to multiply this all by 4. Because it's in standard form. It's like one extra annoying task. So 4y minus 8 equals 4 times 5 over 4 is 5. X minus 3. And now I have 4y minus 8 equals 5x minus 15. And now I'm going to get 5x minus 4y. So here I'll get, 5x minus 4y when I do minus 4y. And if I do plus 15, it's going to give me 7. So 36 is D. So, yeah, the step size was 1.5 in that question. So starting at -1, unless it got answered, if it made sense after. So I'm starting at -1.0. If I go plus 1.5, that puts me at 0.5. You see here, I'm going 1.5, and then I go another 1.5, and that's going to bring me to 2. Okay? So yeah, where did the denominator of 4 go? I multiplied both sides by 4. So when I do 4 times 5/4 x minus 3, 4 over 4 cancels. Okay, this is just notation to say multiply both sides by 4. Okay. Cool. So second derivative parametric. So remember, dy dx, make this neater, is this, but second derivative, don't say d squared y over dt squared over d squared x over dt squared. That's not second derivative for this. So this one, the second derivative, if you have the formula, memorized, it's d over dt dy dx over dx dt. Okay, why is that true? Well, if I take the derivative with respect to x of dy dx, but dy metric, so here's like a little proof. That's the same thing as doing d over dt of dy dx, but then I have to multiply by dt over dx. So chain rule. So now this I'm going to keep together. With this, I'm going to put in a fraction underneath as dx dt. You see, like, it's chain rule plus reverse keep change flip, if that's how you divide fractions. Okay, so that's where the formula comes from. All right, otherwise just memorize it for the AP test. Wait, let me leave it up for you. So, I'll shrink it down in case people want to, copy this if it wasn't up there long enough. All right, we're at question 37. All right, so now let's go ahead and find what we need. So dy dx is the derivative of y over the derivative of x of t. So I have to use the chain rule. I get the derivative of the outside is cosine t squared. Derivative of the inside is 2t. The derivative of x of t is 2t. And it cancels nicely. Just cosine of t squared. So then to find our second derivative, we're just using the formula over here. So I'm going to do this over here. The derivative with respect to time of dy dx. So I do this. The derivative of cosine t squared is negative sine t squared. So I derive the outside, keep the inside, but then the derivative of the inside is 2t. But then I have to divide by, this is the step people forget, which is a real tragedy. Okay, we have to see choice B is like, yeah, like LOL. Don't do this. Choice B for bear trap. All right, that's out. We have to divide by dx dt, and dx dt is still the derivative of the original x of t. So this is gone, and the second derivative is negative sine t squared. Okay, so it gets reused. So that's it. That's what we do. All right. Moving on. Polar. Everyone's favorite. Okay. So here, polar area is this. Now, the concept I like to tell my students is windshield wiper motion. Like if I have a curve like this, let me draw it a little nicer. Something like this. When I want to find the area of, like, let's say this section here, theta 1, theta 2, I think of windshield wiper motion. Like this rotates, but when it rotates, it swipes the area we want. So it's like, as the windshield wiper rotates, it swipes, but the windshield wiper is like magical. The windshield wiper will like grow and then retract depending on the angle. Okay, so that's what's happening here. But now what makes this question challenging is, like, I'm starting here and I'm rotating. Like I'm here, I'm going out like this. But then eventually what happens at some point, my radius shrinks. So now I'll get rid of those. My radius shrinks to 0. I enter the loop. I'm rotating around. Let me just kind of think of this here like this. So like I'm going around, continuously going around, and eventually I enter the loop, and then I exit the loop. Okay, so when I enter and exit, I'm highlighting this whole space here. So that's like what's happening. It's like this space is being highlighted. So the $1 million question is, when do we enter the loop and when do we exit the loop? So I just want to know, like, we enter the loop when r is equal to 0 because we're going to the origin. So we set this equal to 0. Okay, and now this is going to give us sine theta Subtract 2, divide by 4, gives you negative half. So sine, think back to algebra, advanced algebra or pre-calc days, is negative, tells us quadrants 3 and 4. Which makes sense because we're rotating around, and then like past pi is when we enter the loop and exit in quadrant 4. So the reference angle is pi over 6. Because sine of pi over 6 is a half. But what does that look like in quadrant 3? Well, in quadrant 3, the angle would be pi plus pi over 6, or 7 pi over 6. In quadrant 4, it would be 2 pi minus pi over 6, or theta equals 11 pi over 6. So that is what's happening here. Okay, these are our limits of integration. Okay, that's what we're going to use. Slicing pizzas, yeah, however you want to get there. The pizza analogy is how we derive the formula. So I imagine like we take a slice of pizza out. Okay, like that's our cross section is a sector, which looks like a slice of pizza, like cut small. And then like this is d theta, and this is r. So the area of that slice is pi times radius squared. That would be full circle, but we're just taking like d theta out of 2 pi. We're taking a fraction of it. Pi cancels, and you see we're left with 1/2 r squared d theta. So that's where it comes from. All right, so then now I just got to go 1/2 integral 7 pi over 6 to 11 pi over 6 of 2 plus 4 sine theta squared d theta. All right, and then make sure you're in radians when you type this in. Let me open up the calculator. So I got 0.5, math 9, 7 pi over 6 to 11 pi over 6. And then r is parentheses 2 plus 4 sine theta. I use x, close the parentheses around the whole thing, squared dx. Okay, and you get choice A. If you want to go into polar mode, you can. So you could just write, 2 plus 4 sine theta. And then when you go to the main screen, you could just do 0.5, math 9, 7 pi over 6 to 11 pi over 6. Okay, R, I would press alpha trace. And see how it's saved here? Then I could just do this. Same answer. Okay. How do I determine which quadrants? Sine theta is negative when I set R equal to 0. And I use ASTC. And that tells us what we need. Okay. So not quadrants 1 and 2. It has to be 3 and 4. But look, if you have a calculator, honestly, like you could also go to function mode. And I could just type in 2 plus 4 sine theta. And I'll make my window 0 to 2 pi. And see, there's 2 roots. I'm going to graph the line y equals 0. And now watch. Second trace 5 to find the intersection. Enter, enter, enter. That answer, I'll show you how to do that again. I'm going to store that as A. Okay, the second answer, second trace 5. That's my second angle. That's where the equation goes to 0, is here. I press second mode, second minus for the answer, and I store it as alpha apps to get the letter B. And now I could just do math 9. Actually, first let me do this, 0.5. Math 9. So if you don't like the trig part and you have a calculator, just use the calculator to get the roots. Okay, and then I have it saved in Y1. So y1 squared. And now moment of truth. This should work. Whoops, what did I just write? Okay, so 2.174 is our answer. So if you don't want to do the trig part, like you have a calculator, just use the calculator. There's no shame in it. I mean, you get the calculator, you got to be efficient. All right, finally, unit 10. We are in the home stretch. We're going to get to question 50. All right. So here, there's a few things you got to know. Which of the following series converge? P series test. 1 over n to the p. As long as p is greater than 1, your series will converge. Okay, p is less than or equal to 1, diverges. Your series will diverge. So here, I'm like, oh, this diverges. You could also say, oh, that's the harmonic series, the famous series. Okay, if you expand this, that's 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus ... That diverges. This one, P series, converges because P equals 2 greater than 1. This one is an alternating series. Okay, over n to the half. Some people might be like not careful here and go, oh, P series, P less than 1, diverge. But no, this converges. The alternating series test says that as long as you have an alternating series, and if the alternating series has this property that the terms decrease, and this is FRQ friendly. So this you could say in the FRQ. Okay, this is FRQ in magnitude to 0, then the series converges, okay, for alternating series. So here, if I plug in n equals 1, I'm at like -1 over square root of 1. And then if I plug in n equals 2, I'm going to have plus 1 over radical 2 minus 1 over radical 3 plus 1 over radical 4. So you see, like, these terms are shrinking in magnitude. They're alternating in sign, so like we have to account for that, but like the absolute value of the numbers is getting smaller. So since like this sequence is decreasing, like the non-negative part, and the limit of the nth term goes to 0, this series converges. Okay, so that's a big idea that we need to know. All right, the way it's like written in textbooks and stuff, let's just see, is they'll say this. Like, oh, if I have like -1 to the n or n plus 1 times b sub n, as long as like this is decreasing, like the non-negative part, and this, so let me fix that. Like then sigma -1 to the n, b sub n converges. Okay, so yeah, 1 over radical n, that limit goes to 0. My pen is giving up on me. So this part goes to 0. Okay, the terms are decreasing in magnitude, and it's an alternating series. So 1 and 3 only. Okay, 39 is D. All right, this one. You have to know this formula. For a Taylor polynomial about x equals 0, or about any center. Like let's say I just have a center of like A or something. I would have this formula to know. So the nth derivative at A times x minus A to the n over n factorial. So this is like the Taylor series for f of x centered at A. So I call this, f of x equals this. But if I expand it, it's equal to, if I plug in 0, I'm basically just getting, for this part here, I'm going to get x minus a to the 0 is 1 over 0 factorial is 1. So I'm getting the 0 derivative at a. So I'm getting just the function value at a plus this Because when I plug in 1, I get x minus a to the first over 1 factorial. And then this starts to get like more, exciting later on. So let's see. So we have this, and let's see, we got f double prime of a, x minus a squared over 2 factorial plus, and this goes on and on. All right, so here, when they ask us for a third degree about x equals 0 of this, like honestly, I'm calling it just t sub 3 of x, and I'm stopping at power 3. And my center is 0, so that's just going to be f of 0 plus f prime 0x plus f double prime 0 x squared over 2 factorial plus f triple prime 0 x cubed over 3 factorial. Okay, so this is like in general, and this is for the question. So now we start this process up. So I'm going to say f of x is natural log 1 minus x. And then f prime is chain rule 1 over 1 minus x, but the derivative of the inside is negative 1. So I'm just going to rewrite this as negative 1 minus x to the negative first. All right, so then from here, I'll erase this now, though, because we need the space. Okay, so we'll move this up. All right, let's just see. Yeah, I'm doing my best to hang on here. This is 2.5 hours teaching all day. I'm definitely feeling it a bit, but I'm committed. We're going to get to 50. All right, so negative 1 comes down to make this positive. 1 minus x to the negative 2. But when I do chain rule, the derivative of the inside is negative 1. So it makes it minus again. And now third derivative, negative 2 times that negative makes positive 2. 1 minus x to the negative 2 minus 1 is negative 3. Derivative of the inside, though, chain rule makes minus. So these are all going to be negative. And now what I do is I plug in. I'm going to plug in here x equals 0 because I have to find f of 0, f prime 0, and so on. So f of 0 is just natural log of 1 because I'm doing 1 minus 0 is 0. And then I have f prime 0 is negative. 1 minus 0 is 1 to the negative 1. That makes negative 1. F double prime 0 is negative. 1 minus 0 is 1 to the negative second. 1 to the negative second is 1, but that minus makes negative 1. And then now this is where things start to change a little bit. So now I have negative 2 times 1 minus 0 to the negative 3. This makes negative 2. So all negatives. So now I plug into this. T sub 3 of x equals f of 0 is 0. F prime is negative 1 times x. I don't know why I wrote parentheses. I guess I was looking to write x minus something. So just minus x, which it's a or e. And now the x squared term, I have minus x squared over 2 factorial. 2 factorial is 2. And then next I have f triple prime, which is minus 2, f triple prime 0. X to the third over 3 factorial is 3 times 2 times 1. I'll put a times like this so they don't look like x's. 2 over 2 cancels, so the whole thing simplified is minus x squared over 2 minus x to the third over 3. And that matches A. Okay, E alternates, so it doesn't alternate. All right, so that's question 40. Now 41, we're in the final 10. Coefficient of x to the third in the Taylor series for this. So there's two strategies here. For these, we have to be able to represent functions as power series. So this you should have memorized. It will save you. You don't want to have to go, actually, yeah, you should memorize it, but you should have it memorized. Like this is the process to build it from scratch, but you should have popular ones like this memorized. Okay, so here is, okay, the series. So if I plug in 2x for this one here, so let's say I do e to the 2x, all that does is I replace every x with 2x. So I'm going to have this to the third, like this, and now I plug in. So here I'm going to plug in 2x. But the only one that I care about is the, oh, I'm sorry, not 2x. I'm plugging in 3x. Whoops. Well, yeah, let me fix that. So not 2x, 3x. That probably wouldn't have been waiting for us, that answer. That's like a, so 3x. All right. So I'm looking for my x to the third term, which is here. And now for this, I just expand that one. It's going to be 3 to the third is 27. X to the third over 3 factorial is 3 times 2 times 1. Okay, remember, that doesn't mean shout 3 at me. That means 3 times 2 times 1. Why did I write 3? Yeah, I'm starting to fizzle out here a little bit. But don't worry, we're going to get through this. And now divide the top and bottom by 3, and we get 9 over 2. What's that one? Okay, choice E. The second way of doing this is, yeah, we don't need this anymore. If we write the sigma version of e to the x, so e to the x is this. If I want e to the 3x, that's going to be 3x to the n over n factorial. So then I just look here, like, where's my x to the third term? I'm like, oh, that's when n is equal to just 3. So I have 3x to the third over 3 factorial, which is basically the same thing as this. Okay, so that's just another way to do this. All right, so moving on. 42, integration by parts with a table. All right, so here, this one's a little tricky. We're going to find the value of this. So u equals x, dv equals f prime of x dx. du is 1 dx, and v is f of x. Okay, so this we have to know integral of u dv is uv minus integral of v du. If it's a definite integral like this, then I evaluate this from a to b, and I do the integral from a to b. Okay, so that's how I handle that. So now I'm going to use the formula. So this is x f of x from 2 to 5, because it's a definite integral, minus v du is f of x dx, and this is from 2 to 5. Now, they told us the integral from 2 to 5 of f of x dx is 14. So in a moment, I'm just going to say minus 14. But first, I have 5 f of 5 minus 2 f of 2. Okay, that's this part. And then minus this part here. I'm going to say minus 14. But now it's just be careful. Scavenger hunt and be careful. So let's see. We've got 5. F of 5 is 7. So I have 5 times 7 minus 2 times f of 2 is 4 minus 14. So this is going to make, let's see, 35 minus 8 minus 14. And now moment of truth. We're subtracting 22. 13 is waiting for us. So we have an answer. Awesome. I don't really have much more with integration by parts. So maybe I'll throw in like a bonus question here. If I had to integrate something like, I don't know, the easier one is like x e to the x. Then I go like, all right, u equals x, dv is e to the x dx. So du is 1 dx, and v is e to the x. The mnemonic to use is this phrase, liate. This is, log. This is inverse trig. This is algebraic. This is just trig. This is exponential. Okay, so this tells you the order to choose u. So here I'm like, oh, algebraic, exponential. So that's why I'm letting u equal x, because algebraic shows up before exponential. Okay, that's like how I make my decision. And now I just use the formula. The integral is x e to the x minus the integral of e to the x dx. So this is x e to the x minus e to the x plus c. All right, so most of them are like fairly manageable. The most annoying, like, I mean, they could get really annoying, like competition level, but the AP test is not going to make them like too unfair. If I have something like ln x on its own, I could just say, all right, u is ln x, and then dv is dx. This doesn't seem like it'll work, but it does. That's 1 over x dx, and then the antiderivative of 1 is x. So then here, I have x ln x minus the antiderivative of 1 over x times x is 1, and then I have my dx I attach. So this part here simplifies to x, actually let me get rid of that equals, x ln x minus x plus c. That's the antiderivative of natural log. Okay. Oh yeah, DI method is really good too. Shout out to Black Pen Red Pen. He's one of my favorite people on YouTube. I think he uses the DI method. I don't know. I heard Liate way back, and like a lot of kids drink Starbucks. So when I teach it, sometimes I'll be like, "Oh yeah, next time you go to Starbucks, try to order a Liate." And it's just, I don't know. It's a cheesy dad joke that makes me happy. I don't think there's like a DI. I don't know. Maybe like DUI. Like, but that's like kind of a less happy topic than lattes. So yeah, tabular method is really cool. The movie Stand and Deliver it brings me back. So sine t, memorize the Maclaurin. Okay, so the Maclaurin series for this one here. So I'll just say Maclaurin series. So t minus t to the third over 3 factorial plus t to the fifth over 5 factorial, and then minus t to the 7 over 7 factorial plus dot dot dot. If I want to make this over t, then I just divide everything by t. Everything, okay? And now I write the final result. Sine t over t is 1 when I divide, minus t to the third over t to the first is t squared over 3 factorial. And then t to the fifth over t to the 1 is t to the 4. Okay, so this is 1 minus, which basically eliminates everything except this. So 43 should be A. How are we supposed to know? You just look at the answers. See how none of the answers, like it's not like t minus 1 squared if we centered it at 1. So that's the giveaway, is the answers. It's multiple choice. It's sloppy though. They should make it more known, but so at was it Arav? Well, another thing to point out is we have common Maclaurin series to memorize. They don't really have Taylor series that they want you to memorize. It's Maclaurin that they want you to know. Okay, so sine x you need to know. Cosine x, being even, is going to be all the even powers of x. So factorial plus x to the 4 over 4 factorial and so on. And then 1 over 1 minus x is a geometric series that makes x to the n. Okay, so like this. Yeah, so these are popular. Which of the following series is conditionally convergent? Okay, conditionally convergent is when, like, if I have a series like this, like a sub n, if this converges, but this diverges. So if this a sub n converges, but a sub n diverges, then a sub n sigma is conditionally convergent. So it's really just going to be an alternating series that fits the bill, is conditionally convergent. So I kind of just do these in my head. I'm like, all right, if I absolute value this, absolute value just gets rid of the negative 1 to the k. So it's going to destroy all of these, the absolute value. All right, so here I do the absolute value, and it's going to make 5 over k to the third plus 1. And now I know there's that extra plus 1, but then my attention is drawn to this. And I think of the p-series idea that we said before, that if the power is greater than 1, we have convergence. So power is 3 greater than 1. This series converges. We need the absolute value to diverge. So this one is super convergent. It's absolutely convergent. So this one's out. This is the one. Because when we absolute value this, we're going to get sigma 5 over k plus 1, which we could use the limit comparison test with this one here to show that this diverges. I could say, all right, well, I'm thinking of 1 over k. And if I take the limit of if I call this, sorry, the pen is freaking out. If I call this a sub k, and this is b sub k, then the limit as k goes to infinity of 5 over k plus 1 over 1 over k becomes the limit as k goes to infinity of 5k over k plus 1, which is equal to 5. And this is positive and finite, which I'm just going to abbreviate. Positive and finite. So what that tells us is that both series converge or both diverge. But then I could say since sigma 1 over k diverges, and this is because it's harmonic, is the harmonic series, by the limit comparison test, sigma 5 over k plus 1 is also going to diverge. All right, so since the absolute value of our series diverges, but the original series converges, okay, notice here, this is an alternating series. This part, 5 over k plus 1, the terms are decreasing in magnitude to 0. 5 over k plus 1 goes to 0 as k goes to infinity. This will converge, but the absolute value diverges. So this is conditionally convergent. These just both diverge, okay? The original and the absolute value diverge because the nth term test, the limit as k goes to infinity of negative 1 to the k. Oops. This is really just not. I'm going to eventually have to figure out this writing situation because it's either the program or the pen. think it's the program though. I don't want to break up with Notability. Like we've gone through a lot of live streams together, but I don't know. It's kind of breaking my flow every time this happens. So the limit as k goes to infinity is not 0 because see how like the degrees match top and bottom? This just makes it oscillate. It throws it all off. But it's not 0, so this diverges, and same thing here. So definitely B. All right, this one's like, I guess, a little repetitive, but whatever. It's which of the following is the Maclaurin series for f prime, the derivative of f? Okay, so E, I'm going to leave the power blank. Remember, is x to the n over n factorial. So if I put a 2x here, then I'm putting a 2x here. So the derivative of this, okay, the derivative, let's just see here. F is the function defined by this. Which of the following is the Maclaurin series for f prime, the derivative of this? So we could just derive both of these with respect to x. Okay, and now this is n equals 0 to infinity. And I have n times 2x to the, you know what? I'm going to do it an easier way. Sorry about that. I see an easier way to do this already. All right. You know what I'd rather do? I'd rather derive it and then build the series. So e to the x is this, right? We have x plus x squared over 2 factorial plus dot, dot, dot. Goes on and on forever. So e to the, if I take the derivative f prime, let me change colors so that it doesn't collide with what we have up here. F prime, I got a chain rule, is 2e to the 2x. So when I build e to the 2x, this is 1 plus 2x plus 2x squared over 2 factorial plus dot, dot, dot. Okay, but now I'm going to multiply by 2 because the derivative is 2e to the 2x. If I multiply this by 2, I got to multiply everything here by 2. All right, I was just like anticipating an easier way. So you see how this matches right away, choice D. It's 2 plus 2 times 2x plus 2 times this. That was, yeah, the other way just seemed like it was going to take way longer, which is a skill you need when you do these. Oh, Sarah and Sammy, hello, and I'm happy to help. I'm sorry, like this part of the live stream, we're closing in on 3 hours, and I'm starting to crash a little bit. Just a lot of talking, but hello, and I appreciate you all. I really do mean that. 808 people stopped by. Like, that's just so awesome. So thank you all for like bringing this live stream to life. All right. Whew. All right, here we go. Ratio test. All of this, you could just kind of like thought process. If you really understand series, like you could just think of this as like n times 3 over x to the n. This rule from algebra. And this is like a term n versus like, kind of reminded me of like a geometric. It's like a geometric like versus like n. Like geometric is going to win. Whoops. Wrong. Yeah, I just like drag the whole thing. All right. So it's geometric versus, and let me just maximize it so that doesn't happen again. So this one wins. So I really just have to focus on this. And then I remember like, okay, geometric absolute value r less than 1 means converges. So here I'm just thinking of like absolute value of 3 over x less than 1 means converge. So this is 3 over absolute value x. And now just think about it. When is this true? As long as absolute value x is greater than 3, then this is going to be a fraction less than 1. And then like, boom, you're done. Okay, so you just like think about it. Like, yeah, you could get through this pretty nicely. Otherwise, if you're like, hey, I didn't like that, then do the ratio test. Okay, so the long way isn't necessarily the bad way. This is safe. But the other way's got like style to it. Is to go, all right, limit. So ratio test, we have to, do the limit of, this is a sub n. So this is a sub n. So we got to find a sub n plus 1 is n plus 1 times 3 to the n plus 1 over x to the n plus 1. So we're doing the limit as n goes to infinity of a sub n plus 1 over a sub n, absolute value. Okay, but when I divide, I basically just multiply by the reciprocal every time. So a sub n plus 1 is that piece. All right, now I'll get rid of all of this. But I'll just show you we're going to get the same answer. So this is a sub n plus 1. And now I'm multiplying by the reciprocal. That's what happens when we divide. It just, multiply by the flip. Okay, so now algebra. X to the n versus x to the n plus 1. This wins by 1. So cancels out. Comes x to the first. 3 to the n plus 1 versus 3 to the n. The top wins by 1. So now this, maybe I'll just write it up here, is limit as n goes to infinity of, I have 3 over x times, and then I've got n plus 1 over n. So notice what happens here. N over n goes like this are the leading terms. We're going to infinity. So this part goes to 1. So I just get absolute value of 3 over x, which is 3 over absolute value x, which I need to be less than 1. And it's the same argument. This fraction will be less than 1 when the absolute value of x is greater than the numerator. So definitely D. All right. Lagrange error bound. So this one, actually, let me write it like this. So if we have like f of x, and let's just say, yeah, you know what? Times like an nth degree Taylor polynomial is less than or equal to, we would have the, n plus 1 derivative at z times x minus the center, n plus 1 over n plus 1 factorial. Okay, like that's the idea for this one. I'm going to make sure that I should be checking my answers to these as I go, but I'm not. I'm confident in these answers here. But people in the chat, if you ever see something, it's a long process, but I'll show you how to break this down. So if you're writing this in the FRQ, just say like absolute value of the error is less than or equal to, and then blah, blah, blah. Just don't risk writing that. So n is the degree of the Taylor polynomial. Okay. C is the center. And then Z, X is like the value I should say this, the value we plug in. Okay. So how I approach these questions, Z, the famous value Z. Z is the value, so Z is the X value that maximizes the n plus 1 derivative, okay? Which here, they basically told us. Okay, they're going to tell us this. But they use P sub 4, whatever. T sub 4, P sub 4, doesn't matter. So P sub 4 is the fourth degree Taylor about 0. So they just told us a few things here. They just told us like n is equal to 4 and the center is at 0. The series for f converges about x equals, the Taylor series for f about x equals 0 converges at x equals 2. So like this is our x value, x equals 2. Of the following, which is the smallest value of k for which the Lagrange error bound guarantees this? All right, so now we just plug it all in. We have f of 2 minus p sub 4 of 2 is less than or equal to. So n is equal to 4. So n plus 1 would be the fifth derivative at z times, and let me move this over. So now we have times x minus c, x is 2. The center is at 0. To the n plus 1, if n is 4, 4 plus 1 is 5 over n plus 1 factorial. So we get 5 factorial. So this, I could say now, is less than or equal to the fifth derivative. They told us here, this is big. The fifth derivative, the absolute value of it is less than or equal to 3 halves from 0 to 2. So I could just replace this whole thing with 3 over 2. Like this. And now I have times 2 to the 5th power over 5 factorial. Okay, so that's how we're handling this here. And now it seems like it's going to be some crazy stuff after, but they're just taking 3 over 2. We have all positive stuff, so the absolute value just goes away. 3 over 2 times 2 to the 5th over 5 factorial. And this matches this. So A. All right, so just the Lagrange error bound formula, you just got to go piece by piece and just be very careful. All right, if they gave you a graph, sometimes they give you a graph of the fifth derivative. Like, you know, they could have given you like, all right, 0, 2, and then let's say 3 over 2 is here. And this is not part of the question, but like, what if? They could have given you something like, I don't know, that like looks like this. And then like, let's say like after it does like something like this. And then like, let's say they go, oh, this goes up to 3. And then someone like mistakenly chooses 3. The catch is, I should label this more, is that z is between like x and c. Okay, so notice here that our center was at 0 and we were interested in plugging in x equals 2. So I just imagine like we have a number line, like the center of our series is at 0 and at 2. So when we're looking for that z value, it has to be between 0 and 2. So a common trap that they get people with is they give you something more than the interval, but you're only allowed to look between 0 and 2, so you'd have to choose the max value here to be 3 halves. Someone might just go, oh, what's the highest point on the graph? They're like, maximum, and they just choose the highest point, but you're restricted to be between the center and the x value being plugged in. All right, abstract, that's like one of the hardest parts of this. All right. Yes, so fourth degree comes next. So the maximum difference, like, yeah, you're always using the one after, immediately after. Which of the following series converge to 2? So we have this one diverges. The limit as n approaches infinity of 2n over n plus 3. So unit 1 skills, this limit is 2, not 0. So by the nth term test, let me just try that again. So by the, sorry, this is driving me a little insane. It's like just not letting me write. Because if I try to write fast, it freaks out. I have to write kind of slow. So by the nth term test. This is if like it was free response. Sigma 2n over n plus 3 diverges. Okay, so that's out. This is geometric. This is geometric. And let's see, this is negative 8 times, I'm going to write this as like negative 1/3 to the n, which this is allowed, okay? Because like technically I could say there's a 1 to the n next to it, and then 1 to the n over negative 3 to the n is negative 1/3 to the n. And now this is going n equals 1 to infinity. So the formula for a sum of a geometric series, I just go like this. R to the n, it's first term over 1 minus r. Okay? So the first term is like at the beginning of the series, n equals whatever that number is. Okay, so here, this is going to be, and one thing to point out, the series converges as long as absolute value r is less than 1. And here, absolute value of negative 1/3 is definitely less than 1. So this will converge to the first term is negative 8 times negative 1/3 to the first over 1 minus r, in this case, is negative 1/3. So 1 minus r, I got to write minus 1/3, which becomes plus 1/3. Okay, so then here, how is this going to simplify? This is going to make negative negative positive is 8/3. 1 plus 1/3 is 3 over 3 plus 1 over 3 is 4 over 3. And then I could just multiply the reciprocals, but 3 over 3 cancels, and 8 divided by 4 is 2. So this one does converge to 2. All right, then 48, geometric again, r equals a half. Absolute value of a half is less than 1. So this one is first term, which gives me like n to the 0. I would have like 1 over 2 to the 0. That's my first term. Over 1 minus r is a half. And then 1 divided by 1 minus a half is a half. Gives me 2. So 2 and 3 only. All right. 2 more questions. This one's a beast. All right. So, yeah, of course we can't just like end this lightly, right? We have to end in style. So this one, they're telling us the terms of the sequence. If n is odd, like I'm like, all right, this is A1. Okay. This one is A2. This is A3, A4, A5, A6, A7, and so on, right? A8, A9. And then this would be A2, A4, A6, A8. So they're just like defining the sequence here. Like if I want to just pick a random term, like let's say A8, I'm like, oh, even, n equals 8. And when I plug in, it should be negative 1 over 8 plus 1 squared, which is negative 1 over 81. You see? So like that's how, this is like a weird question, but that's what's going on here. Now, which of the following statements are true? The series converges because the terms of S alternate and the limit of the nth term is 0. This is almost correct, but not quite. The problem here is that if I look at the magnitude, so Roman numeral 1, like if I look at the absolute value of like all of the terms, I'm looking at like 1, 1/9, 1/2, 1 over 25, 1 over 4. These do not decrease in magnitude. So I cannot use the alternating series test for convergence. So I can't say they converge because S alternates and the limit of the nth term is 0. That does not work. Remember, it's 2 conditions. The limit of the nth term goes to 0 and the terms are decreasing in the sequence. So that's why this question is nice. The series diverges because it is not true that each term is like decreasing. Like the absolute value of the next term is less than the one before it. Yeah, like while this statement is correct, like it is not true that this part is true. That doesn't mean the series will diverge though. It could still it could still converge. All right, and we're going to show why it converges, although this is not true. This one here is going to be 3 only. So what I want to do is I want to group the blue stuff together. So I'm going to say here S equals. So I'll write it over here. S equals. And now for the blue. I have 1 plus a half plus a fourth plus an eighth. All right, so I'm just grouping all the odd stuff here. The 1 plus a half plus a fourth plus an eighth plus a 16th. So if you look at this series, like just this one in blue, this is geometric. R equals a half. And yeah, if you have R equals a half, absolute value of half is less than 1. So this geometric series will converge. Now the pink stuff. So the pink stuff, I'm going to write minus. And now all the pink stuff is negative. But if I write minus, now I could say 1 over 9 plus 1 over 25. And then plus 1 over 49. And then plus 1 over 81. So this, if we look, is, if you look at this definition here, is the sum of squares, but n is even. But if I just add the even squares, this is like similar reasoning to this. Like how, like, oh, this series converges. Okay, if n is like always even, I could define n to be like, they're like, oh, n is like equal to, let's say like 2k, and k is an integer greater than or equal to 1. Then like 1 over 2k squared, like this series, still converges. So this converges too. Okay, now think about this. I have a converging series minus a converging series. Like if I have like, let's say a sub n sigma, like minus b sub n, and these both converge, then this will equal like some value L. So the whole thing converges. So that's why Roman numeral 3 is true. Okay, that one was a funky question. Sure. But yeah. So group them. Blue converges, pink converges. So when I subtract two converging series, you get something finite. All right. So interval of convergence. So here, ratio test. All right, I'll show it the long way. You could just plug in, like realistically. Let me see here. I would say like in the grand scheme of things here, we're going from -2 to +2. And there's a 0 here, like over here like this. So I would try plugging in the endpoints. Like I would plug in the point that's like, farthest to the left. And if I plugged in -2 for x, I'm going to have sigma -2 plus 1 to the k over k squared. And this makes -1 to the k over k squared, which converges. This is an alternating series where the terms decrease in magnitude to 0. Okay, even I could just do the absolute convergence here. I could just take the absolute value, and the absolute value of the series converges. So the original series converges as well. It has absolute convergence. That means -2 is part of the interval. So this is out because this doesn't include -2. -2 is not between 0 and 2. So this one's out. This one's out. And this one's out. So it has to be part of it. Now, the last thing to check is, does 0 work? If I plug in 0, does the series converge? So let's see. If I plug in 0, I get 0 plus 1 to the k over k squared. 1 to the k is just 1 over k squared. So this converges. P series, p equals 2 greater than 1. Okay, so both endpoints are in fact included. So choice E is it. All right, this one is it. Now watch what happens if I plugged in like something to the right of 0. If I plugged in like, let's say x equals 0.1, then I would get sigma 0.1 plus 1 is 1.1 to the k over k squared. And this, see how like the limit as k goes to infinity of 1.1 to the k over k squared. This would diverge to infinity. So using the nth term test, that would diverge. So that's how E is like definitely looking good. All right. All right. So 3 hours and 10 minutes it took to go through all 50. But thank you all for being here, sticking it out. You know, like bringing this chat to life. And I am going to take a day off tomorrow because I definitely have to rest my voice. But Saturday, 8 o'clock, I'm going to do 10 free response questions. All right. And if I would appreciate, the only thing I guess I would ask is like, help me spread the word. I mean, I think the few days before the test, the algorithm is just going to promote this heavily. But yeah, the more the merrier. But I appreciate you all so much for being here. Like, thank you for contributing. And 880 views, like that's pretty awesome. Like that I have maybe like 80 students of my own, so that's like 11 times what I teach during the day. So thank you all for that. Sorry, I'm like definitely like really tired right now. Yeah, this is like a lot. It's 11:11, so I'm gonna say good night to everybody. And yeah, just happy studying. Don't worry too much. Just put your practice in. Try to relax. The AP exams are going to be over in like 8 days, regardless of how you do. But just, do your thing. All right. I'm rooting for all of you. So take care.